So today we'll do a battle simulation, and we're going to speak about those specific topics, which are physics and ragdolls. So we're using the term ragdolls, but we can do way more advanced stuff than just ragdolls because, as everybody know, ragdolls are not really realistics. We're going to speak about perception and sensors. Within Golem, characters can feel each other and they can feel properties of each other, and we can use this to make a charging army or that kind of stuff, or attacking one character or defending from another character. So you can communicate between entities using perception and sensors. Also, we're going to take advantage of Golem attributes. So far we've been playing with, just behaviors, but sometimes you want to write some data on your character and use it to trigger some behaviors or build some specific, behaviors on the characters. So we'll go through the Golem attributes. We'll speak about channel operators. If you guys, are a bit familiar with Houdini, that's also chops. So we've got our own chop system within Golem, once again, to build your own system of behaviors. And we're going to speak about how to emit entities. In some situation, that can be handy to emit characters from other characters. So in our situation of battle simulation, we're going to emit arrows from archery characters, and we're going to use some physics to make sure that as soon as an arrow hits a character, it just to fall under that collisions here. Great. Maybe before we get started, if you guys got any questions about yesterday's session, I know it was like quite dense and we've seen plenty of new behaviors and new mechanisms. So hopefully it was clear enough. You already know that the stream from yesterday, it's already on our YouTube channel. So if you need to, go back to some specific part of it, you can go at it anytime, but maybe there are any general questions about what we've seen. If there aren't any questions, actually what we'll do today, we'll rely on what we've been seeing yesterday. When you do a charging army, you do the kind of same setup than the one we've been doing, which means go to navigation, locomotion. So we're gonna, benefit from those today. So hopefully you guys can keep with that. I'm not gonna play with unit today, so we're gonna kind of admit that you guys now know how to set the unit properly, and know also that as soon as you set the unit properly, everything will follow, which means every distance, speed, acceleration, gravity, physics attribute will follow and will be scaled the appropriate way. So as soon as you set up the unit, you're good. Great. Let's move to Maya. I can't see any questions, so let's move to Maya and move forward with our first scene. So I figured we'll do probably 3 scenes today. We're going to play with just a basic explosion scene to introduce ragdolls and the different behaviors related to physics. We'll do another scene with a charging armies where we're going to use the sensors, the Golem attribute, and the chops. And we're going to make a final scene with archery soldier, which emit our characters. And you guys will be able to, implement all those systems into a same scene if you need, or put them into a different cache and layout those afterwards if you need as well. Great, let's move forward and let's make an explosion scene. And today we're going to use a brand new character. So we're going to import that character by, as always, getting into the entity type node. And we're going to use today the fortress soldier. So soldier fortress. So as the name tells, it's, a kind of medieval soldier, which has spears, swords, shields. It even has a bow and a quiver to put arrows in. So we're going to play with that soldier fortress guy. So we're going to import it in our scene, and we want to make sure that we load the shaders as well. So please pay attention that there are 2 soldier fortress stuff. There's a soldier fortress arrow. So arrow will be just the actual arrow character. So it's just a mesh of an arrow with some bones on it. So make sure that you actually load soldier fortress as it, and not the arrow version of it. As always, I'm using Arnold here, so I'm going to load soldier fortress AR, and let's wait for Maya to give me the end bag. But this is how does the character looks like. So it has a skeleton, it has plenty of props. we can quickly take a look at the character maker. It has the casual stuff, a spine, a couple of legs, a couple of fingers, and also a bone with weapons. It has a control for the eyes, for the jaw. Well, it's a full character, and you can use that into your own project if you want to. And in terms of geometry, it's pretty heavy. We've got some spears group. So let's move this up. Yeah, it has a spear, shield, swords. We created plenty of different rendering types that you can, use to create variation on your characters. So, and you can implement your own rendering type as well, right? So yeah, let's move forward with this. Yeah, maybe side note as well, which is, well, I should totally speak about this. You know what? Let me take the character maker locator and move this on the side. And you may notice that that character here, it has the skeleton properties, but it also has some physics properties. So what you see here, those boxes, those capsules, that sphere for the head, they represent how does the character looks like in terms of physics. Physics computation is all about collision and reaction to those collisions. So, if we were about to simulate physics on actual geometry, it will be like super heavy, super slow, and not really great. So we need to approximate that. Every time we need to have a physics on a character, we need to approximate that character with some physics shape, which are easy to compute collisions on. So shapes which are easy to compute collisions on means usually primitive, such as capsules, boxes, cylinders, spheres. We've got plenty of mathematics and algebra behind, which computes really easily and fastly collisions between those kind of shapes rather than computing between triangles or quads. So that character here has been approximated with simple shapes, and usually the way you do this is, let me check it. So the way you get the character maker locator on your side is you need to open the entity, your character file within the character maker. So either you open the character maker and you browse your file, or you can go into the entity type and click on the button next to it. It will open the character maker with the right options. And as soon as you do this, now we should create a character maker locator in your scene that you can move into your scene and see how it looks like. So that work here has been done for you already. So, but let me just show you how we did this. So this is a property from the skeleton. So I go back into the skeleton part here, and we've got physics properties kind of panel here with just 4 different buttons. There's one which is edit. So edit will allow us to change that shape here. One is load, to load the physics properties maybe from another character that you did. Reset all to go back to the initial stuff, or reset the joint limits, which is one sub part of the character. If I edit this, I end up with a full complete spreadsheet which has every single bone of the character. Well, every single bone you want to physicalize here. There aren't all the bones here. We remove, conveniently we remove the fingers and the toes. So we kind of remove the physics on those bones there, but every single bone which is not going to be removed from the physics will exist. And up to you to define what's going to be the shape of this. So let's say I'm not happy with having a spherical head. For some reason, my character doesn't have a spherical head. I can go into my head bone here. I can go into the shape there. I can double click on this, and I can just say, this is going to be a box. And I can press the apply button. Oops, maybe I need to validate this, and a box. And now that box, I probably need to provide some dimension on all the axes. So this is why we cannot see it yet. Apply. And now you've got a box on your character, which is 0.14 unit and of half size. So it's the half extent. It's just the middle, the half of the actual size of that cube. And obviously you can take that cube, scale it down, scale it up, reposition it if you want to have something which is more interface UI friendly. So you can just align those two characters together. So I'm not going to apply this. for my character because I don't want them to have you know a cubical head. But yeah, this is where you define your physics properties. So you kind of set up the shapes, place them properly, and then there's some classic physics properties you can set, like mass or density on your characters. You know, like the shield will be way more heavier than your arm, which is just flesh. So those are different densities. So you can set those different parameters yourself. It looks like we haven't done it on that character. So here we have the density of the flesh everywhere, but we could change this if we want. We can change restitution, how much bounciness that bone will be with physics when it falls. Will it bounce on it, or will it just fall and stick to it? How much friction when there's a sliding between two surfaces, how much friction has your body. So you've got all those physics attributes like damping, joint limits, like an elbow only folds into one direction, it doesn't fold the other way. So the joint limits are set up automatically from the pole vectors, but sometimes you may want to change this yourself. So yeah, up to you, you know, to figure this. May take a while. It's usually take, you know, a couple of minutes, like 20, 30 minutes to figure everything on. And when you're happy with that setting here, you just press OK and save, and now you've got your physics properties for your characters. So here that character has been set already for physics, so it's ready to play. The physics properties are done, and you know, we can make it explode and have some nice collisions and nice reactions. If you're really curious about all those attributes and how to set those, we've got a complete video tutorial on our website. I think it's a 25 minutes video, which takes a character which doesn't have anything and show how you build those stuff. And really try also to make sure that when you define your physics properties on your character, that you know, you don't approximate some really small bones. I was referring to the fact that we don't have fingers, so you know, you don't want to put joint limits on every single bone or your finger. So what we just did is we just approximated the character hand with just a box. So if you look closely, you will not have any physics animation on fingers, but most of the time it's good enough, and that make also the physics simulation being more efficient. Okay, so that was like a really quick note about character setup. So now we can move and populate that scene. So I'll let you populate the way you want to, and we'll probably rename this here, the entity type. So I'm gonna rename it soldier character. If you want, you can play with those rendering types. You guys already know how to bring new rendering type in the scene and decide how many of each you'd like to have. I just stick with the default. I'm gonna be happy with that. It's a sword and shield attacker. So it's probably characters with regular props here. So let's populate the scene. Let's put, I don't know, 100 characters or something like this. Here I'm using the grid. Do whatever you want. Now you totally master that pop tool stuff. So create as many as you like. So here I stick with 100 characters as a grid because they're soldiers. So I'm going to do like a legend. And I'm going to orient my characters so they face the same direction than my actual character in my scene. And when I'm happy, as always, press create and now throw the same, and we'll get our characters. They're probably a bit too close to each other. So I'm going to probably change my distance between my guys here. And you know, when you play with physics, you really don't want to have collisions like right away. So I provide like enough distance between my characters. And yeah, that's probably better. Great. So I'm gonna assign them with just a simple motion. So I'll go into my behavior editor, and I open my soldier character shape entity type. And no need to make some complex setup into that scene because we really want to concentrate on the physics setup today. So we're just gonna drag and drop a motion behavior here. So no need to use locomotion, go to navigation. That's something you can do on your side if you want with that character. And I'm gonna just bring a motion clip here, and from the battle motion directory, we have plenty of different clips. So we've got battle animations, but we also have everything which is related to soldiers. So we've got I don't know, a cohort walk. I'm just looking for a walk or a run or something like this, like soldier run. Sounds like something I could totally use here. So soldier run. Let's see if I bring this on my character. Well, okay, the shield is not like at the right position here, but we don't really care. We could use like a set bone. Here, this animation doesn't take into account the fact that we have a shield, or probably it's not the same shape of shield. So we can fix this afterwards with, the set bone behavior. But well, for now, we'll just stick with this. No big deal with this. So my character, they have the same frame posture as as usual. Let's add some diversity for free. Let's change start frame. Let's change speed ratio slightly up and down. Let's bring the mirrored version of that animation. And now we've got more diversity just by changing a couple of sliders. So for sure, my characters, they've got what I was about to say, I kind of forgot. Yeah, they've got collisions because we haven't defined anything regarding collision avoidance. So they're colliding, but well, we don't really care, I guess. It's not really like the purpose of today, well, of not that scene here. We really want to just play with the physics. Great. So okay, all good. So now I expect you guys to have cohorts of soldiers playing an animation, one or multiple animations. And now we're gonna bring some physics. So here, there, let's move into those behaviors. So every single behavior which is related to some physics computation has an exclamation mark within its icon. So here I'm not gonna ask you to guess what is what. So every single behavior which has exclamation mark means related to physics. So you've got 4 behaviors which match that description. So you've got first behavior which is called physicalize, and the quote of that behavior is physicalizes a character body into the dynamics word. And oops, let's go back. Only works if a physics locator has been created. Then we've got the force behavior. Apply dynamic forces to a character body. Only work if a physicalized behavior is running. We've got a detach, and that's probably the simplest description ever, like detach a bone. And yeah, it doesn't have the right tense. It detaches a bone. And we got character controller, which don't even have a description. Okay, never mind. So we're going to use the free first behaviors. So we'll do first is using the physicalized behavior because, physics computation is costly. So this is not something you want to, you want to enable on your character lightly. If you do stadium stuff, most of the time you don't need physics, so you don't need that override of computation. So you need to tell exactly when and on which character you'd like to enable physics. And the goal of that behavior is to actually enable physics on your character. So let's drag and drop that behavior. We're not going to place it yet. I just want to drag and drop it and see what kind of options I can play with. So we're going to move within the attribute editor. And we can see we've got 2 drop downs and a couple of grayed out attributes here. So the first drop down we have just provide us 2 options. So it tells us we can either physicalize or dephysicalize our characters. So we can, make them enter the physics word or make them exit the physics word. Sometimes some characters will not interact anymore with physics. So it's still a bit expensive to have those characters into the physics computation. So we can dephysicalize those guys, remove them from the physics computation. When we are in dephysicalized mode, everything is grayed out, even the drop down, which is here. So let's go back into physicalize here and let's check what's the second drop down. So we've got the default mode, which is dynamic rigid body. if we expand this, we've got another option, which is kinematic rigid body, local servo rigid body, and word servo rigid body. So if you've been playing with physics before, probably in Maya, with the colliders and different stuff, you already kind of know the difference between dynamic and kinematic. So dynamic means that you are fully influenced by the physics. So let's say you've got a motion animation which plays on your stuff. As soon as you turn into dynamics, all the body parts which will be triggered with that behavior will be turning into dynamic. So we're going to apply gravity on those, we're going to apply force on those. But if you turn your whole character into dynamic, it will just be a ragdoll and it will just fall onto the ground, and you'll be able to apply some forces on it and react to those forces, but it's not living anymore, right? It's just a dynamic stuff. When we'll do when you do cars, being a dynamic rigid body is good enough because you've got all the damping and the masses and all the stuff, and you've got the car reacting physically in an accurate way. But if you do, human characters don't fall like this, like without trying to find back their balance or without trying to protect their face with their hands. So if you turn your actual characters into dynamic, they'll just fall dumbly and be ragdolls. So depends on what you're doing. Sometimes that's something you can use. When we'll do arrow later in that session, those characters, the arrow characters, will just be dynamic because there's no brain into arrows. But when you do characters which have brain, they not fall stupidly and dumbly. So, but this is the dynamic mode. Dynamic mode means that no more life in it. It's just physics control. Then you've got the pure opposite. You've got kinematic. Kinematic means that it's full controlled by the animation. If you got a motion behavior running at the same time, your character will be totally controlled by that motion, and physics will not have any impact onto that character at all. So what's the point of having such a mode? Sometimes you're having dead body on the ground and you want the characters which are running towards those guys, that as soon as they hit those guys, the dead body react to this, like they move slightly because they've been kicked. This is exactly when you need to set those characters to kinematic. Kinematic means that they have influence on the other entities which are in the scene, which are dynamic. So they exist into the physics world, but the physics world doesn't have any influence on those guys. So dynamic is the physics world has full control on it, and motion doesn't have any control, and kinematic is exactly the opposite. And obviously, local servo is like, and local and word servo are options which allow you to have both approach. So you still play animation, but you also have physics being applied on you. One example is you move forward, there's a wall, and you haven't put it into your nav mesh, but it's a physics obstacle. So when you hit it, you still want to play that walking animation maybe, but you don't want your characters to go through that wall. So you've got physics which controls that character and make sure that with the collisions, it doesn't move forward. And you've got animation which controls the balance on the character. So local servo, word servo, we'll go probably into the difference between those two later, but there are a way to combine the two modes like kinematic and physics. So if you do World War Z, or if you do that kind of scenes where, the characters, they're physicalized, so they have physics because when they move and when they crawl, you can totally see they collide with the other characters. So there's some physics running, but there's also some motion running because that crawling is something you only get from the animation and the richness from animation. So this is where you use the servo mode. So you bring intelligence to the physics. Great. So that was long speech, but I just wanted you to know exactly the different mode that are here on to our characters. And something which is super important with that behavior here is that it's a switching state behavior. So the design of that behavior is slightly different from the others. I was telling earlier that as soon as that motion behavior plays, the clip which is within it will play along it. That behavior here just switch the state. It enables characters into the physics, or it disables characters into the physics. And the switch happens when that behavior exits. So that's super, super, super important, is that if you just run that behavior, but you don't change that physics, that stop trigger it's having, you will not have anything. It's as soon as you turn off that behavior, so you set a stop trigger to some value, that you'll have some, some actual stuff happening into your scene. So it means that what we'll do here with the physicalized behavior is we're going to put it in parallel of the motion behavior. And the whole goal will be to change its stop trigger to see the actual reaction of my characters. If I just put the physicalize here within the motion with it, when you're going to play the sim, nothing happens. So what we want to do is stop that behavior. So something happens onto those characters. Right, so let's do this. Also, maybe what's the reason for having a behavior which turn on when it exits? We could have maybe have it the other way. The reason for that is while we're gonna have this behavior running, because here it's running onto my characters, it's gonna like accumulate accelerations on the characters while it's running. So when we turn that behavior off, we already have inertia computation on that character. And if we turn the character into physics, if your character was running before, you have all that data which exists, which has been recorded that with that behavior, and the character will fall forward with the right inertia and the right reaction. If we were doing something which starts when the behavior starts, we couldn't really like record that inertia from that behavior. So that's just our implementation strategy here. This is the way we picked. So yeah, just remember this. It's super important. The physics behavior needs to be stopped at some point. So, okay, let's maybe change my trigger here. And I'm going to say that I want my characters to stop that physics behavior after, let's say, 60 frame. So I'll go, once again, super important, I select the stop trigger of my Physicalize. I'm going to open it. And have we played with that frame trigger yet? I'm not sure. I don't think so. So yeah, we want to stop at frame 60. There's something happening at frame CC. So okay, so apparently we played with it. So you guys already know that. Let's see if you remind which one we should use in terms of triggers. So there's like 12, 13, 15 triggers. Which one should we use if we want to stop at this specific frame? So motion time, the clock, the time, the frame, the clock, frame. Yep. Sounds about right. We want to use that frame trigger, which start or stop a behavior by returning true if the current frame is successfully compared to a reference value. So I'm gonna put that trigger. Remember to set it as root. We haven't played with triggers yesterday, so don't forget to set your trigger as a root. So it has it's what takes over what's going on here in your scene. And let's specify that we want the frames to be equals to a value of 60. And just before physicalize behavior, what we'll do, well, let me just make a guess. So don't do it on your side. Let's see if you can guess properly. So here I put my stop trigger at frame 60, and I'm turning my character into kinematic, physicalized kinematic. So at frame 60, what should happen? So different options are my characters will fall at frame 60 with the right inertia. They will run, nothing will happen, or they will run but fall at the same time. So they should fall, run, keep running, they fall, run, nothing, run, keep running, fall at the same time. Okay, I've got everything. Like I've got all the different use cases I've been mentioning. So kinematic, let's see what it does here. So I'm gonna select my character here. I'm gonna see if the Physicalize runs and stop properly. And at frame 60, let's play it frame by frame. We can see the Physicalize behavior stopped. And really happens. So remember, they are in kinematic mode. So that means that they're completely driven by animation. But why do we need that case? Once again, because sometimes you want the characters to react to something. So maybe what I can do is I can make like a soccer ball in my scene. No need to do this on your side. I just want to show you what are the different options with this. So I'm going to make like a soccer ball, which I'm going to turn into a rigid body. We're going to speak about this, and I'll say it's a dynamic object. And when simulation starts, we've got our kicking characters. Where are you guys? You're not kicking into that stuff here. They should be kinematic, so we should totally hit that ball. So, it should work. I'm not sure exactly why it doesn't work. Wait a minute. Kinematic. Damn, it's supposed to be good. Huh. Well, some people are saying that it works on their side. But they kind of, well, I don't know, maybe I did something wrong. I'll figure this later. You know what? I'm kind of, so simulation type dynamic, it's a sphere of radius 1. Inflate. Okay, never mind. But they're supposed to kick into the ball, and they're supposed to, as they're like physicalized, they're supposed to react to this. So let me check maybe the physics shape here, and let's see. I just want to check if I can see my collisions on my characters. Draw the collision shapes, because I'm kind of, okay, it looks like it's all correct. So probably I need to do something more. They are kinematic. So okay, I'm not sure. I'll figure this later, probably during the break, and I'll ask maybe some of the engineers in the team to see if they know what happens here. Okay, never mind. But that's supposed to work, and this is when you need to have the kinematic characters in. So, okay, let's try the other mode here. And rather than saying that we want to kinematic those guys, we want to dynamic rigid body those guys. So what should happen at frame 60 here? Should I keep running, not paying attention? Will they just fall as ragdoll, or would they fall and run at the same time? So fall, they will fall. In dynamic, they die. Yeah, that's a way to tell it. Die. They will fall like ragdolls, fall and run. Eat cheeseburger. Huh, probably. Maybe it's an emergent behavior which has been set when you put soldiers with dynamics. They start playing a weird animation of hitting a burger. Let's see. Frame 60, what's going on here? And my character just fall. So you guys were correct. And you notice that they all felt forward because they accumulated inertia for all the past frame, and they're using this to have the falling and falling into the right direction here. So yeah, correct, they fall, but they do not really fall into, you know, a really realistic way. Once they're dead, it's pretty okay, but the way they fall is not always like super nice. So maybe you can add something more into your animations and into your characters. So I'll go into the third mode here, which is local servo. So what should I expect as soon as I do this? Do they run and not pay attention to what's going on in the scene? Do they like run and fall? Do they just fall like we just seen and they just did? Any idea? That will run and fall, run and react to the ball. I hope they will react. They should react to the ball actually. Fall and try to catch up. Oh, if only we could do that like automatically. That'll be awesome. So servo, the word servo, it's a robotics word. That's the name you use for the motors you put in between articulation, in between two bones of a robot. So you imagine you've got the full arm, the lower arm, and you do a robot, and in between you've got servo motors. So those servo stuff, they're completely physics based. You know, they are motors, so they exist into the physics world. So if you're a robot and you ask on your motor on your arm to move at 90 degrees, but there is an obstacle, um, you know, your arm will just stop with that collision. So the servo motor, which is here, will ask the arm to go at 90 degrees, but it can feel a resistance. So from that resistance, it will just stop and collide, but still try to keep that position at 90 degrees. So this is what servo means. And local servo means that we're going to put those motors every time we're having two rigid bodies. So every time we're having one of those shape, in between, we're going to put motors everywhere, even on the root bone, which is the difference between local servo and word servo. Word servo means that we're going to put this everywhere except the root bone. And local servo means that we're going to put this everywhere, even on the root bone. Let's do this. So let's check what mode I'm in. Local servo, rigid body. So, okay, great. So at frame 60, now my characters, they fall, but you can see they still keep playing that running animation that I have. So obviously here, what should happen is as soon as frame 60 happen, we should also make a transition with another motion, like a motion or characters trying to catch up, maybe 2-3 animations from motion capture or from an animator. And this is where you should bring those to add realism. Some people were proposing that they may fall and try to catch up. There are some papers to do this, but you know, depending on the kind of characters you have, the way you want to catch up is not going to be the same. Sometimes you do animation on some really specific style of animation, so you want to have animators to provide some animation. So we decided not to assist people here. So each of the studio usually make their own falling animations, and this is how you create a really nice and intelligent crowd with some physics on it. So you notice that you play this and they're still playing that run animation, but they are colliding with each other, they are reacting to each other, and they are also falling onto the ground. So let me check. Apparently, I'm having a note for the sphere to make it work. For the sphere, use schematic target in the advanced attribute of the physicalized behavior. So let me check if that's a right way of doing this. So go into physicalized behavior, advanced, use schematic target, and where's my ball? And by the way, the ball actually moved. It looks like it moved. It was like probably kicked by a character at some point. And it looks like this option is not making much. Well, it looks like the option is making my session crashing. Oh no, it's here still. Okay, well, wait a minute. I can totally see that the actual physics of that object is moving, but the actual okay, there's okay, this is like just a Maya refresh stuff. Oh, okay, this is weird. I think it's just like Maya viewport, which is not updating itself, and it's actually moving properly. And yeah, okay, here it is, because if I select the sphere, yeah, okay. So it does interact onto the characters, but yeah, that's just advanced stuff. So no really need to take too much time into this. And let's see if that's what makes the simulation. Let's see here. Yeah, okay, the characters actually push the ball. So I think it's just like a refresh update of the viewport. And we'll have to check this later probably. Great, so let's see the last mode. And let's move into word servo rigid body. So if I use that mode here, what should I get? Should I get running characters, running and falling, falling without running? What should happen here? Just running, just running. Yeah, figure so as well. Just running, but still reacting to what's going on into the scene. So if some characters hit a collider, I should probably make like a rigid body collider. They will stop on it, I think. So let me try do this. I'll just make a box, and I use this as a collider just to try to see if I can make this work. So I'm going to change the 8 of that box, put that slightly above the ground. And this is not the depth, but the white. So I'm going to do something like this here. I'm going to create a rigid body from that guy here, say it's a fully kinematic object. And I probably need to put this later, because at frame 60, they haven't turned into word servo. So let's see if there are some characters which will hit that. So now we've got characters which are kind of step that wall, and they're kind of climbing on top of each other, and they still try to, move on that wall. So they slide on it because they go slightly around it. And now you've got like collisions onto your characters, still trying to make an animation. This is how you get World War Z. You just put a bunch of characters on top of each other. I mean, World War Z, the cone shot. So you put a bunch of characters on top of each other with some geometry from the base, and you just snap them around and let them play some really great crowding animations and in word local servo. So this is how you get that really nice interaction between the characters. Great, but this is totally not the actual purpose of that scene. So I'm gonna remove those colliders, and what we actually want to do today is explosion. So we're kind of good with the physics mode. So we want to probably go back into the local servo rigid body, and which means that at frame 60, my characters will just fall, and this is probably when we should provide another motion clip here. But I don't have any other motion clips. I should probably convert some Mixamo falling animations and put them into the character pack. Well, I'll probably do that later. So we don't have any falling animations that we can take into account here, but you probably now get the idea of aligning the two triggers together. So let's play with another behavior here, which is the force behavior. So we want to let's see, force behavior, apply some dynamic forces to a character body. So, okay, let's bring that guy in. And this is the usual question. Where should I put that guy? Should I put it here, before the physicalize, after the physicalize, before the motion, after the motion, after the full parallel? So some people propose to put it into the parallel. Okay, like in parallel with the rest. After the physicalize, and it triggers on exit, right? Parallel after parallel. So, you know what? I never thought about putting it into the parallel. So let's check. I'm not even sure what it's doing. So let's put it into the parallel, and obviously, while my character are not into a physics mode, nothing will be applied onto those guys. So I fear that nothing will actually happen here. So let's check. I put this with the rest, and go into the force behavior, and we've got a couple of parameters. So first we'll start with a drop down, which ask you to decide what's the type of force. Is it an impulse, or is it a constant force? So impulse happens when the behavior starts for one frame and for one frame only. Like explosion is an impulse. You've got a force at some point which is like blowing you away. So that's boom, happens during just one frame, immediate event, and you get a force from it. So the other mode that we have here is constant force. So constant force is like gravity or something similar. It's something which drags you constantly at the same magnitude and into the same direction. So yeah, gravity is typically like a constant force that gets applied into the direction of center of the Earth. So really up to you here. Let's say you need to drag some character. You've got like a, I don't know, like a UFO, and you want to drag characters which are on the ground. You apply a constant force. If you want to have an explosions in our characters, you just apply an impulse. So we're gonna stick with impulse. Then we've got two different panels. We've got the force direction and the force magnitude. So direction is a vector which tells you in which direction you want that impulse or that constant force to come from. And you've got magnitude, which is telling you how strong that force is. So we'll do with something pretty, regular to get started with. I'm going to put a direction to say, okay, the direction I want to go is on the y-axis. So I'm going to put 0, 1, 0, which is the direction of my impulse. And in terms of magnitude, the unit here is in Newton per centimeter square, if I remember. Well, that's something I do not really master in terms of what it means. So what I usually do is I put some value. If it's not enough, I just put a higher value. So let's put something like, sounds really scientific, right? I'll put a 25 magnitude here and see what happens. But I fear nothing will happen, actually. Yeah, nothing happens, and they're not even falling. So let's see what's going on here. I fear I have an error. Yes. Okay, so now it tells me that I'm not able to apply a force on an entity which is not physicalized yet. So that probably helps into thinking about where we should put this now. And let me check if the physicalize is stopped. Yeah, it's slowly stopped. So where should I put that? Apparently that force behavior is not good here. Where should I put it? After, so I guess it's after the physicalize or before. Some people are saying that we should put it before. Change the start trigger for it to start after 60 seconds, well, 60 frames, I guess. Yeah, that should work as well. But yeah, what we can do is to make sure that the two things run one after another. It really helps to put it after it. And also it means that if I change my physicalized trigger, I will not have to change my force trigger afterwards. So what I just did here is, that was my settings before. So here, there, let's remove that container. You can just drag and drop that force behavior and make sure you don't drop it on the parallel. Make sure you drop it on the slight tiny piece of flow that you're having right after you physicalize. So put it after the physicalize here. And when you can see that orange, that flow arrows turning orange, now is a good time to drop it. And you can see that now you've got your physicalized, then you've got your force. And if we run our sim at frame 60, okay, we've got our characters all at the same time, flying up into the air, still running, colliding with each other, falling pretty heavily on the ground, and keep running. So yeah, kind of almost what I wanted to do. Just checking, you guys were able to have this on your side as well, have like exploding characters playing some animation. Yes, yes, yes. Nope, didn't work. So if it doesn't work, let's make sure that first you've got the right setup. So this is my setup here. I've got a motion behavior all alone. Then I've got my physicalized behavior first, which turns off after 60 frame and switch into a force. Great. Okay, I can see there are questions which hasn't been answered for a long time, so I guess it's for me. Is there a way to gradually reduce the servo strength? Not into the UI. I'm pretty sure that's something which is available within the API, but we haven't exposed anything regarding this. But it's actually quite a good feature request, and we can probably figure some good use cases to use that. Alex, I'm not sure if you're hearing this, but if you can put this question aside and we're going to log it as a feature request, I can totally use this later. Also, quick questions. It's well, tricky question here, but here the characters, they fall back into the ground. We applied an impulse on those guys, and there's like a common rule which tells them that there's gravity here into that scene. Where does that gravity comes from? Let's say I'm in a really low gravity environment. I'm on Mars, let's say, which has a third of Earth gravity, I think. A third or maybe two-thirds, I'm not sure. Well, it's lower than Earth. Let's say I need to change my gravity parameter. Where would that rely? Where would such a parameter be? Let's guess this. Is it something you guys will put into a behavior? So some people, so first answer, I'm getting into the crowd manager. So into the physicalized behavior, into the physics locator, is if it's working as the nucleus. So I guess it's kind of, yeah, okay, it's referring to the physics locator with some constant force. Yeah, true. We can totally have a constant force which maybe like opposed to default gravity. That would totally work. We can put this in as a parallel with our physics system, and that would totally work. But that's just more stuff you had into the behaviors. So would work. That's a way to go through. But indeed, the gravity is written. Apparently, it's written somewhere. So some people propose to put it into the manager, and it's true, it will be a great place to be. But the thing is, let's say you need to have a different gravity for a different group of person. If you put it into the manager, you don't have a chance to put it separately for different characters. So manager will be a great way, but actually we have on top of manager, or below manager, we also have like locators, environments, I think we called those. If you yesterday we were playing with the traffic locator, and we've got plenty of different locators. We've got the terrain, we've got the physics, we've got the fog, the perception, the traffic. So those are kind of words in which my entity lives, and I can have multiple of those words and have multiple simulations which are using different words into the same scene. So if you check into your scene, as soon as you play with some physics behavior, you end up automatically with a GLM environment group, which when you expand it as a physics node, which is a physics locator. And when you open it, you can see some default attributes such as what's the environment mode. So right now we're using a default plane. It's true that the characters, they're not falling below the plane, because by default we're using a default plane which is infinite and at 8,0. And you can see that right below you've got something called gravity. So gravity is 0 minus 981 0. So this is Earth gravity. We figured that most of the case people would like to simulate Earth conditions. So Earth gravity tells you that you want to be attracted by Earth center at a gravity of minus 9.81. So you're attracted towards. Let's say I want to have a space gravity. I was about to say the answer when I was about to ask the question. I want to be in space. What's the gravity in space? Yep. 0, 0. So let's try that. Let's put a 0 gravity. It's not exactly true wherever you are, but we're going to kind of figure that's true. And you can see that as soon as you apply an impulse of those characters, they just like in space. Nobody hears scream in space, but also if you go into one direction and nothing is here to collide with you or to slow you down, you just keep moving into that direction here. So let's say we want to be on Mars rather than Earth. I don't know how much Mars gravity is, but let's say -6, and you have a different physics simulation. And this takes into account, obviously, the unit. If you were about to work into a separate unit, that would be no need to multiply this by some factors. So yeah, this is Mars gravity here. So characters go higher there. Great. Let's go back to my Earth gravity, and also I actually wanted to show you yesterday when we were starting to play with terrain. I wanted to show you how you can have um, multiple terrains in your scene, and decide which terrain will be applied on which characters, because I figured some of you guys made multiple terrains in your scenes and you couldn't really, you had weird behaviors where you had your borders or you didn't have your borders in your scene, and your characters were not following this terrain or were not following those borders. um, so there's some stuff which are happening for you in the background, so I just want to let you know exactly what's going on, so if that happens to you later, you know how to fix it on your side. So what we'll just do is I want to have Earth gravity applied on some characters and Mars gravity applied on other characters. I want them to share the same behaviors. So what we'll do is we're going to create another crowd population. So we'll keep the same entity type with the same behaviors, and I'm just going to create another population tool here. And I'll put maybe slightly less characters, but doesn't make really any difference. I'll face them the same direction here, provide some distance, and here when I'm gonna press create, before I'm gonna press create, what I'll do is I'm gonna say I want to emit those characters into a new particle system, and also I want to use a new crowd field. So make sure that here you're saying that you want to use another crowd field, because this is where you're able to set different terrain. So by saying that you want to those entity to live into the different crowd field, that there can be different simulations with different general attributes, such as the terrain, the physics locator, and that kind of stuff. So right before you create your characters, really make sure that now you set them into a new crowd field, and when you press create, now you end up with one pop tool, a second pop tool, one particle system, a second particle system, one crowd field, a second crowd field. So really make sure that when you are in the the pop tool, you go onto new here and new there as well, and you create an actually new system. Great. If I run the sim, those characters behave exactly the same way for now. They applied with the same gravity, they fall the same way. So far, so good. So maybe let's speak about that crowd field. So we can open the first crowd field, which is those characters there, compared to that crowd field, which is those characters here. And if I open the crowd field, I have some, we play with some attributes already. We play with the enable, disable, where we wanted to have, put some characters. We validated those characters and we don't want to use some computational power for those guys. So we kind of remove those. You can have, the start frame. You can change the entities to simulate in your actual group of crowds. And something which is quite interesting is here you've got the environment attributes. So you see you've got a list like the terrain, the physics, the flock, the perception, and the traffic. And all those guys are set to use the manager terrain locator, use the manager physics locator, use the manager flock locator, use the manager perception locator. And those two guys, each of those guys tell that they are using the default manager terrain, the default manager physics, the default manager stuff. So let's go into the manager, see what's into that guy. So the manager is the crowd manager. It's that node here, which is the central node here. And here as well, we've got a environment attributes panel, which is closed by default, but we can expand this. And as soon as we expand it, we can see that in their scene, we don't have any terrain. So there's no terrain locator. So that means the crowd field inherits from that properties, and they don't have any terrain either. The physics, it's set up to physics shape 1, which is my physics system, which was created by default. And let's maybe rename this like physics earth. Up. So manager is using physics earth locator. And for the rest, we don't have any of those guys, so they don't exist. So the manager used the physics earth. So that means my crowd field, they both use the physics curve. So let's say I want to change this. I don't want my crowd field 2, that bunch of guys, to use the same physics properties, the same shared physics properties. I want to have my own system just for those characters here. And same goes for the terrain, by the way. You can create a terrain for one kind of characters, and you can create another terrain for another kind of characters. So this is exactly what you can use. And just a side note as well, here into the manager, we're going to register only the first node which is created. So let's say you have multiple terrains, you create multiple terrains, only the first one will be recorded into the manager. So this is maybe why some of you guys yesterday had some issues with terrain assignments onto your characters. So yeah, make sure that this is the right terrain which is used if you're having multiple terrains into your scene, because it's always only the first one created which will be assigned. So what we want to do is assign another physics locator to that crowd field. We want to override that attribute. So I can go into, there's no way to create a new physics locator from the shelf, because it's really unusual case where you want to create your own physics locator, but you can do it still from the Golaem menu, environment locators, and then you've got the physics locator button here. So if I click on this, it's going to create another physics locator that I can rename physics on Mars. I can reduce that gravity. Maybe I can put, well, you know what? I can actually like increase that gravity. I'm going to make it like really high. So I'm going to put like -100. So it's not Mars. It's probably, I don't know, one of those big planet, maybe Jupiter. So I'm going to say, okay, physics Earth -9, physics Jupiter -100. And now I can turn, go into my crowd field, go into the physics locator, and I can say, for that group of characters, the physics I want to use is physics Jupiter. So I put a gravity of 100. So what would happen here? Are they going to be flying higher? Are they going to be flying lower? Are they going to be exactly the same than the rest? Have a guess. Lower is the first answer I'm getting. Barley fly up, fly lower, lower. Yeah, I think they they might not even lift because the force I've provided will not be. I think they're just gonna face plant heavily into the ground. That's my guess. But indeed, they get applied with a different physics now. And when frame 60 starts, yeah, okay, they lifted because the force was high enough, but they just face plant on the ground afterwards. So that's just a way, to have different different locators, environment being assigned onto your characters. It's 7:05, so I'm kind of almost done of what I wanted to do with that scene. So let's make a 5-minute break. So it's 7:06. So let's resume this in 5 minutes at 7:11. And we'll do explosions on those characters right afterwards. And I haven't saved my scene, so probably now is a good time to save it. Okay, see you in a minute. Damn, it's way above the time I said. Sorry. Okay. So what I want to move out with is making an explosion. So we kind of have all the basics of here, all the building blocks. But the thing is, when you do an explosion, it's like coming from a specific position. Here I'm having a vector which is the same for everybody, so they're all flying up. But the explosion is kind of located somewhere, and depending on where it is, based on the character position, he'll have a different impact and a different reaction onto my characters. So first, in which behavior should I tweak those? So let's check what we have. We've got a motion behavior. We've got a physicalized behavior. We've got a force behavior. So in which behavior I should change that data? So I've got a force shape answer. Well, force, where do you guys put this? Animate the magnitude. Yeah, the magnitude is going to be like the force of the force, the importance of the force. So we'll just have like a different height on my character, but what I really want to have is like having them, if it happens on their right, on the left, I want them to move to the right. If that happens on their right, I want to move on to the left. Maya field, yeah, we can totally do that if we want. That would totally work. We've got a magnitude locator. So, okay, that sounds like something I could apparently use. So let's check what we have actually. So in the force direction here, first I can reset back this to 0. And every single attribute that you have here accumulates with the other ones. So the final direction which will get applied onto the characters is going to be the addition of that word-based direction, character-based direction, locator direction, PP attribute, which means relies on attributes, expression, so you can write expressions as well in the specific Golaem syntax, and a noise, which will be different for every single character here. So locator means that we can have a position somewhere in the word which will define the position, the start position for that impulse to be applied on the character, and that can really look as an explosion. So I'm going to create a locator for my explosion that I'm going to put here. And as always, if you want to map it, you need to select it first. Then you need to press Shift and select the force behavior. It's still the same stuff. And once you've got your locator and your behavior selected, the force behavior selected, now you can map it into the direction. And let's see how it looks. So now it tells this is the start direction of my impulse, and depending where my characters are based on that locator, you can see they are having like a kind of radial approach here. The character on the which were on the right, they get pushed into the opposite direction. So you have to imagine like a vector which goes from the locator positions towards the actual entity position, and this is what will define the direction of my magnitude here. Pretty great. And if I want to have flying characters, I can probably put my locator below the ground. So now the vector will also move my characters up. So before it was just snapped onto the ground. So my character were kind of attached to the ground and sliding on the ground. And now we've got like really more an explosion where characters are flying into separate directions. Excellent. So far, so good. Something, if we want to, be really realistic, here we can see that the explosion has the same impact on my character. The closest character, they receive the same magnitude than the character which are really far from that explosion. So we also want to change this. And if we pay attention to the force behavior, now into the magnitude, we also have like the magnitude locator. So now we can specify from a distance how much force will be applied onto my character. So probably the locator I want to map will be the same than the direction one. Can be convenient to use the same stuff, but you've got the options to use different one if you want. So I'm going to select my locator once again. I'm going to shift, select my force behavior, and I'm going to map that locator back into the magnitude locator. From the moment I map those two together, you can see that the 4 following attributes, they grade in, so they not grayed out anymore. So they become active. So I'm going to put, once again, what we do is we add every single magnitude together. So we're going to add that word magnitude with this and this and this and this and this. So I'm going to put this down to 0 first. And I'm going to say at minimum distance, the minimum distance of my explosion is going to be 0, maximum distance. And you can see that as soon as you change the maximum distance, you've got a display which appears into the scene, which kind of represents the influence of that force. So this is like the maximum distance here. Great. When my characters are at the minimum distance, when they are the closest from the locator, I want to apply a 25 force. And when they are at the maximum distance, I want to apply a really small force of maybe just 1. And that means that the closer you are from that locator, the more impacted you'll be, and the less closer you are, the less impacted you'll be. And here we've got something more organic. Notice that influence sphere will only appear while you select the force behavior. If you unselect the force behavior, it just disappears from the viewport. If you select it, you've got it back. And it only appears if your min distance and your max distance are at different values. Great. So let's say I want to do the opposite. Here it's an explosion, but let's say it's going to be a black hole. And I want all my character to converge into that locator position. What do I need to change? What attributes I need to change, and what value should I put into this? So negative magnitude. -1, negative magnitude. Yeah, put the magnitude in negative. Yeah, that's the correct answer. Invert mean and max. I'm pretty sure we've got within the code like a check which makes sure that those two line up properly. So that should be ignored if everything goes well. Yeah, negative magnitude will be fine. So you now tells that magnitude at min distance is -25, and magnitude at max distance is -1. And the next time you throw the same, you've got all the characters converging to that locator with different forces. And what we can do also is maybe say, like a black hole is not something which, well, I haven't seen one obviously, but I don't imagine it's just one impulse happening just one frame in time. It's more like a constant force. So probably if we want to do this, we can make a constant force rather than an impulse, and we should have all the character being dragged. You can see that those characters here, as soon as they are into the sphere, they get dragged into the middle of the scene, and you've got kind of black hole stuff. And we could make those characters disappear by using a kill behavior. But yeah, I like it. It's pretty sweet. Does it work with traffic? Yeah, totally. Every single behavior is interoperable with the others. So yeah, you can put some physics behavior onto your cars, detach stuff. Oh, and by the way, let's detach stuff. We haven't detached anything yet. So let's detach bones. You may have noticed that I turned my display into a physics display. Usually that's my way of working. As soon as I play with physics behavior, I tend to really like working with the physics display. so I can see what's going on in terms of physics collisions and see what and see if that's working as expected. So you change that mode when you go onto your entity type and you go into the display. So you know, we've been playing with cylinders. That's usually also my default display when I play with navigation. So I make sure that everything is fine in terms of avoidance and so on. You've got animation bones, which just display the bones of the characters. You've got physics shape, which displays you with the physics collision of hulls. And to make it nice and pretty for your director, you can just turn it into render previews, so you can see how does the GPU skinning looks like, and it looks like a bunch of weird characters stacked on top of each other. But yeah, it's fine. So yeah, I kind of like to put the physics shape. So up to you here, but that's just a convenient way for me to figure what's going on. So we want to detach some stuff now. We want to detach, especially we want to detach weapons. So you guys already know there's a detach behavior. And what I want is as soon as my characters start falling, I want them to detach their weapons. So where should I put that behavior? Should I put it in parallel with the rest? Should I put it after the physicalize, after the force? Should I put it on top of the physicalize, in parallel with the force, in parallel with the motion? So parallel to force, after the force, after the force, parallel with the motion. After the force parallel with the physics. Okay, so something I could see pretty often is after the force. So if we put it after the force here, if I select a guy right now, anyone, you can see is still playing that force behavior. So if I put it after, I will not see the impact of that behavior while that force behavior is running. So that's not exactly what I want. What I want is really when the physics turn on my character, they drop their weapons. So indeed, putting it in parallel with the force will be the right way of doing it. So I put my detach here, and what I'm going to do is I'm going to release it on top of the force. So as soon as you can see the force blinking in orange, drag and dropping. So now you've got your physics, so your character will start falling. They get the constant force right away, which bring them into the center of that locator as a black hole. And we're gonna detach stuff. So let's see what's the parameters which are available. Well, there's just one parameter to set into that behavior. Is probably one of the simplest we have. I think there's one behavior which doesn't have any attributes in it. I think the kill behavior doesn't have any attributes, so there's even simpler behavior. But detach behavior just tells you which bones you'd like to detach. So I'm going to say I want to detach weapon underscore L, weapon underscore R, but you can do whatever you want, but pay attention. Wait a minute. Don't do whatever you want. I'll show you why you can't really do whatever you want. So let's first say, okay, I want to detach my weapon L, weapon R, and what I should expect now is when my characters fall, you can see that here and there's some spears, shield, which have been detached from my characters, and they get attracted, obviously, from the blue hole, but they are detached from the character. If for some reason you're having issues with this, probably it's because you're having multiple entity types, or I don't know, just write it up. You can just write weapon, so respect the camel case here, so it's uppercase W, weapon underscore L, you put a comma, weapon underscore R. So this is just a helper window, but maybe if you got a blank entity type, let me check if we put a blank entity type here. If we put it detach, yeah, okay. I should totally fix this. So I'm having, you can see here, I'm having the same error than you if you got a blank entity type. Usually people don't have blank entity types. So remove the types you're not using. That will fix the window, or just copy and write this up yourself. And I'm going to write this down to fix the script which belong to that attribute. So it's multi types plus bone helper. window, and one of the type is empty. So yeah, if you remove the default, the anti-types which you are not using, and go into the behavior now, that should work. Great. Excellent. Is there something else? Yeah, I wanted to, tell you that you can't do anything with this. So let's go back into my skinning mode. And this works because the bone is attached to only one mesh. Obviously, if you break the neck of the character because you want the head to move apart, that's not going to work because the head is actually going to be, as some skinning on the neck, some vertices of your meshes are impacted by that head mesh or that head bone. And if you move that head bone away, the skinning will just follow. So if your character skinning has not made to take this special case into account, you've got really weird stuff. Let's say I want to detach the head of my character. I'm going to detach here, and I'm going to select the neck, for example, and I'm going to apply this. Now, the next time I run the sim, I've got my simulation, and now you can see that you've got a lot of weird stuff going on. You've got heads, which are detached, so exactly what you expect, but you've got those, all those vertices here because your skinning has not made properly for this to work. And obviously, if you are into, let's stop the simulation. If you are into physics shape, you don't see that. You just see your actual bone, your actual bones being detached, and you say, okay, this is working properly, and you're all good, and you export your sim, and you say, okay, it's all working. And when you turn into render previews, you said, okay, no, that's not correct, and I need to fix my geometry. So yeah, pay attention when you detach a bone. Remember that it's also going to influence the skinning of that character here. Great. So let's go back into removing the neck, and we're kind of good, I guess. So there are plenty of options into the force behavior. I'm not sure if it's released yet, but we also have a way to got torque. So if you got to have, if you want to make a tornado will have a varying magnitude and direction along the tornado. So we've been adding something regarding this. I can't see it into that interface, so I'm pretty sure it's going to be into the next release. Maya field, or maybe into it's probably into the next release, but we've implemented also a way to have torque, so we've got twisting characters on top of do stuff. Great. We're good. Is that everything I wanted to show you on this scene? So yes. So maybe let's go back into into our previous setup here. Yesterday, we kind of reviewed some of the shots, and we figured we could actually do that ourselves. So that's something we couldn't do yesterday. Here you've got exploding characters, which are playing nice animation. So now you know how to do this. You ask an animator to make you a couple of falls, and you use the local servo with some triggers to bring your characters. Physicalize. If you want to make Game of Thrones Season 7 and win an Emmy Award for that specific sequence, exactly the same. You've got a volume trigger, which is bind onto the flame of the dragon, and you turn your characters into physics at the moment they are into that volume. This is locomotion go-to. We've seen that. That's classic stadium stuff. And we're good with this. You guys know how to do that now. You know how to do this. You know how to do this as well, because we've been playing with Flux. We haven't played with the perch, but you can play with the perch and help yourself with this. Fling from background, do some League of Legends cinematics, and work with Digic. And I wanted to just show you, I'm not sure if it's in the reel. Let me figure. Yeah, here it is. So you've got World War Z kind of shot where all the characters hit the wall. They converge into the same spot, but they just hit the wall, play some physics, and you got all that piling up of characters going on. This is using the wood servo mode. quadrupeds. We haven't really seen quadrupeds, but you can pay attention to one of the assets we have into the character pack. There's a horse, so you can check how it's mapped. Nothing really fancy. Horses have legs and arms, so they're exactly the same way than us. They have locomotion the same way than we do. They turn, they run, they walk. And you've got, yeah, that's a really nice shot as well, where you can have great flying people in the background playing some animation to try to keep their balance. And that's something you also get from the local server. So yeah, you kind of do, with what we've seen so far, you cannot do everything which is into our reel. So the best shot we have into our reel kind of rely on the same behaviors we've been seeing. Okay, so I'm kind of happy with that scene. Let's save this, and we're gonna move to something a bit more complicated, I'd say. More powerful, but more complicated, with great power, blah, blah, blah. So let's go into a new scene here. And I'm going to save that. And what I want to do, my use case is I want to have a battlefield. So I want to have two entity types, and I want my soldiers to look for each other. So soldiers of camp A, they look for soldiers of camp B, and vice versa. And I want them to, find the closest entity and move that in. And I also want some characters to die as soon as they've been attacked by other characters. So here we want to, kind of make a small video game system where we program what's going to be the target position for my characters. And we also want to program some health point or something like this. As soon as they hit enough, they just die. So we're going to rely on triggers, and something we haven't seen yet are going to be sensors and perception. So entities can perceive what's going on into the scene. So we're going to play with those. So let me check questions. Before ending the explosion, I've got one question. How do we activate an animation after the explosions? Like into the reel. Maybe I can quickly go back into my scene. Soldier explosion. So let's say you want to, bring another motion behavior when this happens. So first thing probably is to, and that will be also a good opportunity to show you how you can share triggers between behaviors. So first, this is my run animation. Let's rename this run. And what I need to do is probably create another behavior afterwards. So I'm making two sequences, my physicalize and my force detach, and here I run. And I'm going to load anything else, like a rest animation, let's say. Probably would be better to put a fall animation here. And let's rename this, let's say fall, even if it's not a fall animation. So what you'd like to have is you want that behavior to stop at the same moment than this behavior here. So let me check what I have as an option. I was pretty sure I had this. Had stop trigger, remove last stop trigger. Okay, no, never mind. So what we'll do is we'll figure, so here we can like totally recreate the same trigger. I can say, okay, at frame 60, I want my run to stop. And you can put the same trigger here, and you'll have your run stopping at the same time, then you physicalize, then you go into the explosion, and you play a falling animation at the same time. So that will be one way. But if for some reason you change that trigger, it means that you need to change the other trigger too. So that stop trigger here, it's called BE Physicalize 1 Stop Trigger Shape 1. Okay, it's a complicated name. Probably we can rename this like frame 60 trigger. So that's better. So what I'll do is go into my run behavior, and what I want to do is share that trigger with that behavior here. So I'll go into my run. I'll go into my run behavior. And if I close everything, you can see I've got every single behavior I'm having triggers attributes. So I can expand that triggers attribute, and I can see that the trigger which is used to start that behavior is called run start trigger shape. And the stop trigger is called run stop trigger shape 1. So here I can go into the drop down and probably change the one I want to use. So I'm going to say I want to use frame 60 trigger shape. And when you now select that trigger here, you can see it selects also that one there. So now those two triggers are shared. So that behavior will stop at the same time that that behavior. So they're kind of linked together. And to make sure it works, I can select a character, that guy here. So right now it's running, it's playing the run animation. At frame 60, we'll see that now Physicalize has been changed for detach and force, and now it's playing the full shape animation. And within the behavior editor, we can see that now the Physicalize has just stopped, the run has just stopped, and now we're playing the full, and at the same time we're playing the detach. So that's just a way to sync your start behaviors and stopping behaviors together. So hope that makes sense, and also that's also a good opportunity to show you shared triggers and how you can sync those two together. And now you've got the characters falling and standing. So we're not playing that running animation anymore. We're playing that stand animation where they're like standing still as soldiers. Okay, let's move on. Let's save that scene and let's move into a different scene. So we'll start with a really small setup. We're going to create our two types. I'm going to create, and we're going to use Soldier Fortress together. So for the two types, we're going to load the Soldier Fortress. So here, Soldier Fortress, we're going to load the shaders, Soldier Fortress Arnold. So I end up with one type, and I'm going to name this right away. I want to make sure that all my naming is going to be right into that scene. So I'm going to call that Soldier A. And I'm going to create another entity type, which uses Soldier Fortress 2. Well, Soldier Fortress as well, not Soldier Fortress 2, the number. We don't have Soldier Fortress 2, the number. So let's call this Soldier B. And probably also to make sure I populate the right characters, I want to turn on their colors, like full power. I want my characters from Soldier A to be green into the viewport, and I want my characters from Soldier B to be blue into the viewport. So I go into my Soldier A, I go into the display color weight and pump this to 1. So now we're telling like my characters that will be full blue will not show any textures. Great. So let's do our setup. We'll do just a test layout, and we're going to expand that layout later. So we're just going to have maybe, I don't know, 50 characters against 50 characters, and later we'll put thousands of those. So this is my battlefield. Once again, we're going to stay with the meters unit. So this is like 1 meter, one grid here is 1 meter. So I'm going to put some green characters here and some blue characters there. And I want them to face each other. So I'm going to create, well, once again, you know how to use this now. Put some distance between the characters, change the orientation so they face the wrong direction here. I want to make sure that I only have green guys there. So I'm going to my entity types, put my Soldier B to 0 there. And I want to go into another pop tool, which is also 60 characters there, which has an orientation opposite. And I want to make sure that I only have blue guys there. Change my distance, noise lose a bit. I'm going to change my distance here as well into my population green distance noise. Okay, and when I'm done, I'm going to create one crowd from that particle system and one other crowd from that other particle system. So no problem if they are into the same crowd field, different crowd field. Here we don't have any advantage or disadvantage to using one or the other. And if I run the sim now, I should get green characters here, blue characters there. So my two populations facing each other, and I'm going to play with different behaviors for those guys. I'm going to save that scene into my project. Let's call this 06 Soldier Charging. Great. Okay. So we're mainly going to concentrate on the green characters, but you can replicate the same behavior on the blue characters later if you want to train yourself with this. So first thing we'll do is we'll do a casual setup where we want our characters to, go somewhere, and that somewhere will be my entity position. And we want them to avoid the obstacles and find their way. So we're going to use, the casual setup we've been using yesterday. So I'll go into my soldier green, soldier A, open my behavior, and I'm going to drag and drop go to behavior, classic, navigation behavior, put it in the same spot, and we're good. So I'll let you process this. Just do it right now on the green characters. The blue characters, right now they don't have any behavior, but we're gonna play with that if we got time, or you'll be able to replicate this the other way later. So right now, only the blue characters, the green characters, I assign them with some navigation and assign them with a target. And what I'll do is right away, I'm going to group this. So I'm going to select my parallel, and I'm going to press Control G, and I'm going to put a container around it. And I'm going to rename, so I'm going to close that container. You can open it or close it within the flow. And I'm going to rename that container find enemy. Great. And probably what I can do right away as well is to create another container into my flow that I'm closing right away. And I'm going to rename this attack enemy. Okay. So find enemy, attack enemy. So I've got my two sequence of big blocks of behaviors I want to assign. So find enemy will be a navigation and a go-to. So my characters will find the enemy and reach it. And when they're close enough, we're going to make some fight animations here. So this is kind of the structure of my stuff here. Great. So next, I want to probably provide a target to my characters. So let's see what options we have. So let's go into the go-to behavior, and by default, they're saying that they want to reach a random target into the environment. So we probably want to change this. And we've got multiple options here, and you can do battles in different ways. But one way I would like to take advantage of is using the Golaem attributes. So too quick on your manipulation. Which manipulation it is? The grouping. Well, okay. Let's say I've got a blank space here. I'm gonna remove that one there, and remove that one there. Here we go. So I was just assigning go to navigation. Once you've got a setup, which is already here, you can use Control G to make a transform around it, a group around it, the same way you would do it into the outliner, that you can actually close and rename a way which is convenient to you. So here I rename it find enemy. Let me remove those from my scene so I don't have any name conflicts. Up there and there. So I'm going to rename this find enemy. And I'm going to make another block of behavior. So what I can do, so the behavior container, you can use Control G to create it, or use you can also bring it from the operators. The first icon you have here is also a container. So it just creates a default container. So you can drag and drop it, put it into the flow right afterwards. It has two views, open or closed, if you want to hide or see what's in it. So let's close the two of them. And on that one here, we want to rename this attack enemy. Great. So let's expand that one here. So this is my go-to behavior. And what I would like to do is I would like to have my position of my enemy being stored into a Golaem attribute. So on your characters, you can add as many attributes as you want to, and you can use those attributes to store some data. So they can be seen as variables. So if you've been doing some programming in the past, so this is a variable which is attached to your characters that you can fill the way you want. So the way you create a Golaem attribute is by selecting your type. So let's go into my green characters type, I can go into the entity type attributes, expand that panel. And from that panel, we can see that now we've got a Golaem simulation attribute panel that we can expand as well. And we're invited to create a new Golaem attribute on those characters. So that means that on the green guys right now, I can attach a new variable, and that variable, we call this a Golaem attribute. We could also use PP attributes, so attributes per particles, because the characters, they're actually also attached to a particle, so we could like benefit from PP attributes. But as always, fetching data from Maya, it's a pain in terms of performances. The tools are not so efficient. It's not multi-threaded, so we've got a complete different way which works exactly like PP attributes. Which allows you to have something which is working way faster. So we're going to create a new attribute. We can name that, provide a name to this attribute. So we're going to name this probably enemy position. And from that drop down here, we can see that we can select between 3 different types, either float, integer, or vector. So here, I would like to store an entity position. What type should I use? That's an easy question, I guess. Vector, float, vector, vector. Okay, so we kind of all agree that a 3D positions need to be stored into a vector. So vector, well, is a kind of it's a short name for vector free, because vectors are just any size of number lists. Here it's a vector free. So vector free means it's 3 numbers, and we're going to use that vector to store the X, Y, and Z coordinates of a character. With a float attribute, we could only store 1 component, so that will not be enough. So I'm going to change that enemy position attribute to a vector, and I can provide some initial value here. So right now, my initial value for my enemy position is 0, 0, 0, which means the scene origin. Great. So now we've got our entity position attribute. So far, so good. And if I rewind the sim and I run the sim again, yeah, we miss a terrain. We'll fix that later. I can go into another shelf icon we haven't been through, which is called the attribute spreadsheet. And I'm not sure why, but I don't have tool clips anymore. Looks like Maya decided to remove those. Yeah, okay. Sometimes it just decides to remove those by itself. So yeah, this is the attribute spreadsheet. So it looks like a spreadsheet icon. And when you hover it, it tells you this is the attribute Golaem attribute spreadsheet. Open the Golaem attribute spreadsheet. It's the it's the worst helping message ever. But whatever, it tells what it does, right? It opens the Golaem attribute spreadsheet. And when you open it, you end up with the actual attributes you've been creating on your character. So you can see all your entities, which have an enemy position vector attribute, which is made of 3 different floating value, which right now is set up to 0. And we can see that at the end, we also have the blue entities, but the blue entities don't have that attribute available. They belong from a different entity type, and we haven't created it on those guys. So those guys don't have anything here. So this is why it's grayed out. So this is just a great way to check what's the value of your attributes right now on every single character. So great, well, we created our first Golaem attribute, and this is exactly what the attributes are. They're only variables that you can add onto your characters and populate later with something. If your list is empty, you need to rewind the sim and rerun the sim for a couple of frames. If you if you don't have any characters, we don't have anything to fetch it from. So you need to instantiate a simulation. As soon as you instantiate a simulation, you should get an attribute working. Those attributes only exist when simulation exists. So yeah, that's one takeaway with this. Great. I can close that spreadsheet stuff. So let's pay attention to that message that we have. So here it tells us that we've got a missing terrain while using a navigation behavior. I guess we also have a forbidden sign on the navigation behavior. I can click on it, which tells me I have a missing terrain while using the navigation behavior. And probably here, yeah, wow, we've got the same script editor message. So apparently it needs to have a terrain. Even if we don't have any obstacles, it needs to have at least a default terrain. So I'm going to create a default terrain just by clicking on the terrain locator icon. If you don't have any obstacles or you don't want to, create a nav mesh, you can just create a default terrain ground. So I'm going to click on this. It's going to create a terrain locator, which is a default plane for ground adaptation, a default plane for the nav mesh, and we should be good. So for now, my entities, they go random. So I need to change this. Great. So, okay. So far so good. We've got a Golaem attribute on our characters. If I do select it, I was expecting to see that attribute. Well, we'll see that with other behaviors. There are some ways to see what's the value of the attributes also when you select a character. We'll see that later. So what we want to do now is to say enemy position is my actual target for my go-to behavior. I don't want my characters to go randomly. I want them to reach enemy position, and later we'll create some behavior to populate that enemy position attribute. So I go into my go-to behavior here, and I'm going to change it from random target to target expression. So target expression means that now we can write an expression which gets evaluated for my characters, and where you populate that target expression, it's kind of hidden into. So you can see here you've got the pop tool attributes for the target, the curve attribute for the target, the mesh attribute for the target, and then you've got like a panel which is used for the rest. So we've got an other target mode attribute which is closed by default. So let's expand it. And as soon as we expand it, we can see that we've got in target expression, and probably we can populate this with our attribute. So I know that there's a bug with the UI, so maybe you're not able to do this or open that window on your side. But what we want to do is actually say what we want is read enemy position. So we're going to write out enemy position. And we've got like a particular syntax here. So like every single entity has an enemy position. So you need to tell from which entity you want to read that enemy position. So you want to use the keyword this. So this means I want to look the attributes at myself. So I'm going to type this. I'm going to say what I want to look is an attribute. So I'm going to put a dot, this dot attribute with 2T at the beginning, dot enemy position. So this is the correct syntax. I want to fetch an attribute on myself, which is called enemy position. So yeah, the UI, I know that the UI probably on your side is not great. So best is to write it yourself. So once again, we were onto random target. What we decided to do is to say we want to use a target expression. That expression is the name of the attribute I created on my character. So enemy position. I want to read the enemy position from myself. So the keyword is also a programming keyword in C++, which refers to itself. So this, you need to put a dot, which is our separator. This dot attribute dot enemy position. And now you're saying that where you want your characters to reach is enemy position. Let's save the scene just in case. So now I should expect my characters to reach my scene origin, because we've got a 0, 0, 0 enemy position. And we've got all the characters gathering to the 0, 0 position. So apparently it crashed for a lot of people. So what was the last thing you guys did when it actually crashed? And did it work for some of the people, or are all of you guys are restarting your computer? Okay, it works at least. Okay, it works for at least a couple of people. It worked here. I think it crashed because the position vector was empty. Well, it's not empty. It has a default value. Some of my guy move, the rest don't move. Well, I guess same as myself. I've got, you know, my green guys which are moving, my blue guys which are not moving. Make sure that you haven't populated, you know, that field, that population tool with blue guys. Make sure that you really have separated your characters. Added Golem attribute rewind and play. Crash after write expression. Okay, that's weird. If that happens again, you can create dump files and we can take a look at it. So the way you create a dump file is if you're able to make a scene crash like constantly, you can go into Golem settings. You can enable crash report and specify where you want to write this. And the next time you will crash, it will create a specific file for us to take a look at, and we can see exactly what's going on. Well, if some green are moving and some are not moving, the best you have to do is to, you know, click on it, check which behavior they're running, and for some reason, are they not playing any behavior? So maybe you need to change your triggers or whatsoever. So the right way to figure this out is just selecting the character and see what's going on. Also remember that by default, they're gonna go at 0, and when they reach 0, they will not move anymore. Yeah, check this. Would you go again through the position attribute you created, please, really quick? For sure. So what I did is I'm going to rewind my sim. I'm going to go back into not having anything here. So you need to create an attribute on your characters. So on soldier A, I went into the empty type attributes. I expanded this. I went into Golem simulation attribute. I expanded this. I said that I want to create a new attribute called enemy position, which will be of type vector with some initial values of 0, 0, 0. So to make sure it works properly, you can rewind the sim, play just one frame, and you can open the spreadsheet to check if that attribute has been set properly on the characters and that it's an actual vector. So you actually have 3 attributes here. Then you need to go into your go-to behavior. Say you want to change the default mode from a random to target expression. That expression can be controlled from the other target modes attributes. And here into in target expression, I said that what I want to reach is this dot attribute dot enemy position. So reading the enemy position from myself, which is an Golem attribute. And from that point, if we run the sim and run the sim, now you've got all the character converging to 0, 0, 0. Great, it's 8 p.m. on my side. So probably from that point here, it's also a good time to make a break. In the meantime, I'll put, today's session sum up in case of people want to check where we are. So we've been doing physics and ragdolls, we've been doing Golem attributes, and right now we're going to jump into perception and sensors and channel operators at the same time. So yeah, see you it's 8:01, so see you into 15 minutes, so 8:16. I'll try to grab a dinner quickly. Feel free to speak to each other if you guys are stuck in position. Maybe you can ask the community. Make sure that you send message to all panelists and attendees, and maybe some people can jump in and help you out. Oops, forget my glass. Okay, let's come back. And this is the final line of that training. Let's go. Do I assume that you guys will have like converging to 0 characters? You guys good? All good, all good, all good, all good. Well, if you don't have it anyway, you know the stream will be available later, so you can catch up. Okay, most of you guys are good with this. Excellent. So we can move forward and now introduce something new, which are sensors. So what we want to do now is to fetch the closest enemy position. So my enemies of my green guys, they're here. They are my blue guys. And I want for every single of those to figure what's the closest position. So let's do this. So to what we can rely on is perception. And perception means that we can attach to every character a custom geometry. So we can create a whole geometry and that will be attached to the character and that will use as a perception zone. So let's say I do a cylinder super big, and I'm gonna say this is a sensor on my character. This is a new perception on my character. My character will be able to feel anything which is within that area, zone, geometry, call it the way you want to. And on top of that, on top of what you perceive, you'll be able to filter the type of stuff you want to have. You can say, okay, I just want to feel obstacles. I just want to feel characters. I just want to feel characters which are alive. So you can filter those and you can order those the way you want to and write them down into an attribute, for example. So here we'll be able to figure what's the closest character of type blue, which is still alive, and write that position of that guy into a Golem attribute called enemy position, for example. So we're going to do that. We're going to create a new locator, create a new geometry to define our perception. So let's start with this. What I'll do is I'll create a cylinder. To be honest, that's probably one of the simplest shape I can make here. And I'll make that cylinder big enough for my character to cover the distance between my soldier A and my soldier B. And anytime you can change that cylinder size into your scene, and that will be updated onto your characters. So I'm creating like a cylinder pretty big. And also remember that the position it is, that cylinder, compared to the scene origin, will be the position compared to the character. So you'll have to consider that your character will be here at the scene origin, so that cylinder will be attached the exact same way. So if you move that geometry into the world, it will have an offset compared to your character. So probably you need to, also provide the right 8 so it represents exactly what you want your characters to feel. So you can change slightly the 8 of that cylinder. So this is exactly what my characters will be able to feel. I'm gonna rename that object, that cylinder, like a distant sensor geo, and you can hide that geometry so it doesn't really bother you into the viewport. Great. So we have hidden it, but it's still into the scene. So I'm gonna select that geometry I'll go into the Golem. Wait a minute, is there a shelf button? Yeah, there's a shelf button. So no need to go into the Golem menu. We'll go, so select that geometry here, and we're gonna select a new button we haven't spoken about yet, which is the sensor locator. So once that geometry is selected, you can attach a sensor to it. So now you're saying that sensor is gonna use that geometry. And by the way, um, you can have multiple geometries. It can be a combination of geometries. Here I'm just using one cylinder, but if you want to have a cone with a sphere, with a cube, whatsoever, because you design your own perception, that's something which will work the same way. So I'm selecting my geometry here. I'm selecting my sensor, and now it's creating a new node into the scene, which ends up into the GLM environments group. So within the GLM environment group, you can expand this, and you've got something called sensor 01. So I'm going to rename this sensor distant. And that just tells that this is what I'm going to use to field the characters which are really far from me. And you can have as many sensors as you want onto your characters. You can have a sensor which is filtering what's on your left, a sensor which is filtering what's on your right, what's above, what's below, and you can connect this with triggers and react to this. So you can like make a complete attacking system by perceiving what's going on for your character. It's kind of vision. It's not really vision, but yeah, it's perception. This is what we call it. So once again, we've got a sensor here, which we created from a geometry, which is our cylinder, which is here. The size of and the position of that geometry is really important. So make it centered to 0, 0, the scene origin, which is the default place for geometry. Else it will be offsetted compared to your characters. So here you can see my translation. I just slightly move it up. So it's above the ground. And this is my actual geometry. So I selected it. I pressed the sensor button, and now I have got something I call the sensor distance that I'm going to use to filter my entities. So let's go into that node here, and let's check what we can tune into this. So first, it has a in Maya geometry list, which has all the geometry which represent my sensor. It has how many voxels we're going to use to approximate that geometry. We're not going to use the geometry right away. We're going to voxelize this. So we're going to break that geometry between 10, 10, 10 voxels in every single dimension. What's the depth tree? So this is like optimization parameters. You don't really need to take this into account. Then you've got simulation attributes. So you're going to tell what you want to filter. So here you can pick between Golaem entities or navigation mesh obstacles. So what we want to fill is actually Golaem entities. And we've got a detection period, which tells us how many, what's the frequency we want to evaluate. So every 6 frames, we're going to refresh what we perceive. So 6 frames, 1/4 of a second if you're in the 24, 25 FPS. Great. So now we are able to fill something with that sensor, and we need to assign it to our character. So we're going to stick with the default attribute. We're going to tweak those later because we're going to need to tweak those later. So I'm going to save the scene. And what we want to do is attach that sensor to that green character. For now, it doesn't know anything about, the simulation. It can be attached to the green, to the blue. So it's really up to us to say, we want to activate that sensor. Once again, it's like the physics. In terms, it requires a couple of performances to create that perception for every single character. So you really want to tell the system when you want to trigger this on and trigger this out. So obviously, if you want to trigger this on and off, it means that it's a behavior. So let's go into the behavior editor and let's see what behavior we can take advantage of. So quick guess here, maybe looking at the icons, is there any icons which look compelling to you? And if you hover it, what will be the name of that icon? There's something which, would make sense. So someone figured there's a behavior called activate sensor. When we speak about sensor, sounds about right? Activate sensor. Yeah, you guys add it correctly, and we try to design the icon the right way too. So you've got, that T-pose character with a kind of radar next to it. And you've got that icon here into the behavior editor, which is like a walking character. So it's a behavior with that radar. If I hover it, I've got activate sensor. Activate a sensor on an entity only works if a perception locator has been created. That guys get created by default, so we're good. So okay, let's bring that in. And where should we put this? So that behavior here will tell while it's running that we want to evaluate what are the Golaem entities next to me. So where should I put this? Should I put it before, at the same time than the navigation and the go-to in the attack enemy? So first answer I'm getting is parallel and parallel, parallel, parallel. You kind of all agreed. Someone suggests after, parallel with nav and go to, parallel with navigation. Yeah, you guys are correct. So that activate sensor will run at the same time, and every 6 frame it will update the position from the over entities, and we're gonna run it while we are still looking for an enemy. So at the same time, we want to look at an enemy, we want to evaluate what's the entity position, the closest entity position, and feed that behavior. So they're all going to work in collaboration together. So I'm going to drag and drop it and put this within the parallel. So make sure that you drag and drop it when the parallel blinks in yellow. If you drag and drop it on the container, you'll notice that the behavior disappears. That's because it is in your container, so you can double click on it, and now you can connect it to your parallel, and you can control double click to go back to the previous step. So make sure that when you drag and drop it, you drop it on the parallel being appearing yellow here, and you can release this afterwards. And now you've got go to, so we go somewhere, at the same time we navigate, and at the same time we're going to feel the other entities. Probably will be a good time to rename that behavior tool. So we're going to say feel distant entities. Great. And let's take a look at the attribute of that behavior. Once again, it's pretty simple behavior here. It takes a sensor list. So here we can map as many sensors as we want. I'm adding a distant entity sensor, but I may create one later, which is like a close range sensor that I may want to enable it also. So you can have as many sensors as you want into your scene. Once again, you can have for your left side, right side, above you, below you, behind you. You can create different shapes and really play with that. So what I'll do is I'll just connect my sensor. So I'm going to select my sensor from my scene, the T-pose character with the radar. I'm going to press Shift on my keyboard, select my activate sensor behavior. So here it's still selected, and I'm going to map those two together. And just by doing this, we shouldn't see anything into the simulation. It doesn't have any impacts, but we can check if our sensor is working. We can select the character, show the visual feedback. We can see that now we've got a fill distant entity shapes behavior running, and we can enable visual feedback onto that sensor. And now I can see what my characters is able to see. So my characters, they're able to see mostly green entities next to each other. Can they see the second entities? Oh, let's wait a minute. Let me check. Sensor IIBB3. So no, I don't want to have this. I want to see the perceive objects, and I want to see the sensor geometry. Okay, so it's clearly not big enough. So let me show you what I just did. What I had is, this is what you get on your side. So you select an entity, you can see is playing navigation, is playing the go-to, is playing the activate sensor. That activate sensor, you can see that you can enable visual feedback. So let's enable it. Now we can see our geometry, our cylinder, and we can see what the characters they actually filling. So it's filling mostly green entities on his left, forward, and back to him, which is what's happening right now into that sim. And if I select that guy, for example, you can see that is mostly filling characters which are behind him and some blue guys which are here. So every single character fills something. So you need to run the simulation for at least 6 frames to get this being updated. It updates every 6 frames as we define into the sensor. And here I was kind of curious to know why that character does not show any blue entities. So I went into the Maya viewport settings. You know, there's more settings you can play with, the same stuff we've been doing yesterday with the cars. So I expanded this, and I can go at the right end, right after the car attributes. You've got something called sensor geometry, which is disabled by default. So you can enable it and you can see how does your cylinder looks like applied onto your character. So we can see it's not big enough. And we can also enable perceived entities, and we can see which entities get perceived by my actual character. So just a great way to figure if your sensor is working properly. So this is what the character sees right now. So it's not big enough for a requirement. So that means, what does that mean, by the way? What should I do? Apparently I cannot feel my blue guys. What should I do? Resize, resize. Yeah, correct. Scale the cylinder. Exactly. Scale the cylinder. So I'll rewind my sim. Go into my distant geo, go into my cylinder, pump that radius so it covers exactly what I want. So let's say it's big enough. I can hide it. Once this, as I said, rewind the simulation and click on the character and okay, and probably I need to enable and disable the sensor geometry, or what's weird that it doesn't update the viewports. Okay, when I look at the sensor AI BB3, it looks like it's correct, but it's just probably just an update issue here. But whatever, I can see that the perceived object now are fine. We are feeling those blue guys, and from the view here, you have to do it. Oh, okay, I have to launch it 2 times. Let's see. Yeah, okay, me too. Thank you for the tip. Now I'm getting advices from the people I teach to, which is good sign actually. So yeah, I have to run as advised. I had to run the simulation twice for the geometry to update, and now we can see that we are filling the character. So once again, I need to run it for at least 6 frames, and afterwards, now we can fill the blue guys. Great. So far so good, but there's probably one issue here is that if I'm asking what's the first entity, what the closest entity I can find, it's probably going to return me with a green entity, which is my closest entities are the people from soldier A. So we'll need to maybe change our sensor slightly. So we're going to see what kind of attribute we have into the sensor. So let's rewind the sim. Probably saving right now is a good time. And I'm going to my sensor distant. And we can see that now we've got, well, now we had it before, but we didn't really pay attention to it. We've got something called filters. So we can add some filters to filter what we actually perceive. So let's see what we have. We've got a drop down here, and those are the different stuff we can apply to the filters. So let's take a look at the list. So what I do is I just want to keep the blue entities. So what filter sounds about right about keeping only the blue entities? I've got something called a AND operator, a OR, a NOT, max count, nav mesh visibility, sort by distance. I've got crowd entity type, PP attributes, or Golaem attributes. So crowd entity type, yeah, kind of looks like the major answer that I'm getting. Crowd entity type sums are about right. So I'm going to select it from the drop down, and I'm going to press on the plus button to add it as a filter. So now we've got a new filter, which is of type crowd entity type. So let's remove it, and I'll do it once again. So I'll go into my filters, I select crowd entity type and press plus, and now it adds a new filter, which is a crowd entity type filter. If I select that filter, I can see that my UI updates automatically, and I can specify which entity type I'd like to keep. So this is what you keep here, what you want to, the filter is only to keep, this is the rules of what you keep into your perception. So what I want to do is I want to select soldier B and press plus. So now the used entity types for that filter is soldier B. I'll do it once again. I remove this. So what we want to do is go into the sensor, and we only want to keep the crowd entity type of type blue. So I'm going to select this, press plus. Then I'm going to, within my filter, I'm going to select my crowd entity filter. I'm going to select the type I want to keep. So those are soldier B are the blue ones. And I press plus. And now what I'll do is only keep entities of type blue. So great. It means that next time I throw the sim, now you can see that those green guys, they're not here anymore. They are completely filtered by my sensor. And now what I'll feel is only the blue guys. So, okay, we're nearly there. And if I check the visual feedback, well, I can see that now I'm only taking into account the blue guys. So next is I want to keep only one, and I want to take the closest one. So is there another filter maybe I can use? So let's check the list once again. So let's go back into, the filters have hierarchy. So let's make sure that you always go back into the major stuff into your selection, else you'll do a hierarchy building. So yeah, let's see what options we have if we want to keep only the closest one. So someone proposed to use the sort by distance, sort by distance, sort by distance. Sounds about right, correct. So make sure that you're on the filter, you've selected the filter, go into sort by distance, and now add it. So what we do is first we'll filter only the blue guys, then sort by distance, and by default it returns a list of the entities being the closest to the latest. So if let's say I remove this for now, and for that entity here at frame, so let's run that at frame 9. The first entity we can feel is 1002. So this is the default order. Let's say I now had a sort by distance filter. So I'm going to put this here, select here, had a sort by distance, and run the sim again, and go at frame 9 once again. Now we've got a different order, and now the characters are sorted by distance, and I've got my closest entity, which is 15002. So sounds good. And last thing we want to do is we want to keep only one. So let's go back into my filters, and let's see how I can just keep only one into my list. What other type of filter I can use? I've got an answer which tells max count. Max count, yeah, sounds about right too. So let's select max count here and press plus. And now I've got at the same level, first select the blue guys, sort them by distance. You can reverse that if you want to have the furthest entity. And max count, let's put this to 1. And now we'll have, if we launch the simulation again, so I can select the max count, go back to 1, and run the sim. And now I should get only one blue spot, which is my closest entity. And that may change while I'm doing the simulation, when my characters move. That may change, but now I know that what I want to target is 15002. Sounds good. Let me check what we can do from that data here. I want to get a position, and right now I just have an ID. What else do I have? Probably PP attribute, Golaem attribute. Okay, usually also I'll put some elf points. I put some elf points on my characters to also filter if they're dead or not dead. Here we don't really have the time to do it, but what I'll do is usually I had a new Golem attributes on all my entity that I called elf points. It's usually an integer or a floating value, and if you know that value is superior to 0, I can also filter this. So I just show you. You can also like add. No need to do it on your side. You can go back to filter here. You can go into Golem attributes. You can press plus, and here you can put the name of attribute, and you can say if it's superior to 0, which means the characters is still alive. So we're gonna fetch for that attribute on the characters and see what we get. So it's also one way to make sure that you don't target a guy who's dead, and you know, that's not weird. So for now, my characters then do not reach the blue guys, but they just know about one blue guy, and that's it. But they just go, you know, to 0, 0, 0, and we'll have to do something to fetch now the position of that entity. So now comes the time. Remember what we were supposed to see today. We've been seeing perception and sensors. Right now we've seen Golem attributes. So let's introduce now channel operators. Oops, let's go into Maya, and now we're going to bring another behavior which will be able to translate that blue ID into a position. So that behavior is called channel operator behavior, and okay, the description is pretty scarce. Manipulate channel values. It's the behavior you can use to build behaviors. It's a meta behavior. So you can use that behavior to, you know, build your own navigation system if you want to. Avoidance, motion tree triggers. You can build, like, you know, a full video game kind of AI using that chops. So here we'll do pretty simple steps, but I'll try to walk you through that channel operator behavior. So that channel operator behavior, we're gonna rename it update entity position. So that's gonna be its goal, updating entity position. So let's rename this update enemy position. There we go. And that behavior will run at every frame. It will convert my closest entity ID into a position. So where should I put that guy? Should I put it with the rest into the parallel? Should I put it before? Should I put it after? Should I put it into the attack group? Parallel again. Parallel, parallel, parallel. That even some people who have shortcuts to make parallel rather than writing the whole word. Yeah, sounds about right too. You guys get the mechanism here. So make sure that you drag and drop it on the right spot. So now we've got something quite complicated. We've got a go-to behavior, which go into a specific position defined by an attribute. We've got a navigation behavior, which defines the avoidance strategy. You've got a sensor which updates the position of the character, and well, which fills characters, or I would say it that way. And we've got a channel operator which will translate that ID into a position. To be honest, I'm not really sure how to do it yet. So I'm kind of investigating how I do this, and I'm still trying to think about it. I should have probably prepared that lesson well. It's not a behavior I use often, so well, now you see how you can go through that behavior if you don't know anything about it. So that behavior looks pretty scarce, and you can't really tell from looking at the UI that it can do really powerful thing. It's because actually it hides another editor. I've been like opening it here and there, not having spoke about it, but actually, yeah, here that behavior will be controlled by a different nodal editor, which is like really channel operator based. So if you've been playing with Houdini, I guess it will be more something familiar to you guys. So what I'll do is I'll start creating a new output channel. And you can see that from that button that you create, now you've got an output channel, which is called chop output shape 1, that you can enable, disable, that you can delete, recreate. And you can see that now you have a icon that you can open from a specific editor. So I'm going to click on that icon here. I can probably like move my behavior out, my behavior editor out. And well, I've been probably like opening that editor earlier into my scene. So my behavior update enemy position, it writes a value from that node here. So it's a chop output shape 2. So it's that guy there. Yeah, that's because I created I created one and deleted it. So it still exists somewhere. But this is where I'm gonna write my stuff out. So this editor here, it's a nodal editor, same stuff than before. You control it with middle mouse and Alt key to move in. You can zoom in and zoom out to see your graph, and you're gonna create your operations within it. So this is the output. This is where the graph ends, and you're going to connect nodes to it and create some operations. So this is kind of visual programming and write values out. If you press tab while being into that editor, and it's true, actually, it's true for every single node editor within Golem, but even more with that one, which doesn't have any icon, where the UI is super dry. You don't have any icon you can drag and drop. So the only way to access those nodes is by pressing tab, but that works into the behavior editor, that works into the character maker, into the layout. It's a pretty casual UI shortcut. You've got different types of stuff. You've got a input node, sensor input, operation converter, multiplexer, accumulator. I'm not sure if we'll have the time to play with all of those and outputs, but what we'll do, so let me think about it. So what I need to do is fetch what I have from my sensor and make a position out of it. So probably I'll need a sensor input. So let's create a sensor input and let's select it, and let's see what's available from that guy here. So I have, wait a minute. No, I think, okay. I could do it that way, but I feel it's going to be a pain because I'll have to do multiple graphs. One to fetch the ID, put that into a variable, one to convert that ID as a position, put it into a variable. So, okay, I'll do it differently. Let's remove that sensor input. And I think I've got an handy way of doing this. I can tab this. I'll just create a chop input one. Okay, and so let's rename my nodes, by the way. This is, my output is write enemy pose attribute. So this here will write the value we're going to push into my Golem attribute. And this here will fetch closest blue entity. I fetch closest blue entity to the input of my right enemy position attribute. And yeah, that's it. That will be the graph we're going to do for that use case. But I'll probably show you the graph from Game of Thrones. The customers was kind enough to share what he's been doing. So at the end, I'll show you how you can what you can get if you got a heavy brain. So once again, to create a node, it's going to be the same within every nodal editor, but we haven't had a chance to play with that. I just press the tab key. The tab key allows me to see the list of all the nodes which are available. And here what I just did is I just create input node, so chop input, and I just connected that chop input to my output node. So Green node input, you can read data from the simulation. Red nodes are outputs and yellow nodes are operations. So this is where we can put some sin, plus multiplication, etc., etc., etc. So okay, let's configure those two nodes, and I think we'll have something working just by configuring those two nodes. First, we want to say that here we want to write the data which comes in into our enemy position attribute we've created on my green characters. So by default, my output node tells me that what I'm going to write into is a Golaem attribute, but you can write multiple stuff. But by default, it's a Golaem attribute. And what's the name of that attribute? So we're going to replicate the exact same stuff we've been doing before. So what we want to write into is enemy position. You can grab it from the helper next to it. And where you want to write it is on yourself. So once again, you're going to say this dot attribute dot enemy position. And this tells you that now everything which gets computed from here will be written into this dot attribute dot enemy position. But if you want, you can tackle the actual position of the actual character. You can change a bone position or orientation with attributes. You can write a PP attribute. You can directly change the speed of your character, the orientation of your character, which is used for the locomotion. Remember, that's something we've seen yesterday. Rather than having a navigation behavior, you can write your own navigation based on what your characters see. So here, what we really want to do is just write a position into Golaem attributes. So this dot attribute dot enemy position. Great. Let's see if we write just a simple position here, if the graph works. So we want to create maybe just a vector. So I'm going to use inferior sign to tell it's a vector. So it starts with this, inferior stops with superior. And I'm going to do, just maybe 10, 0, 10. So 10, 0, 10 means 10 on the x-axis. So this is the x-axis here. So means that I want to send my characters to position 10 on x, 0 on y, so it's elevation, and 10 on z. So I want to send my characters basically to that position here. So let's check if everything works. We've been specifying that we want to do is write 10, 0, 10, write this into, oops, let's frame this back. Aha. It's always a challenge to frame that guy out. Where are my channels? Yeah, they are. Yeah, as the interface is quite dry, it's a pain to deal with. Okay, not sure why I cannot zoom that out. Anyway, let's say, okay, what I did is write a vector, say I want to put this into my enemy position attribute, and if I run the sim, I should get my character gathering to that 10 by 10 by 10, 10, 0, 10 position. And if you want to make sure that everything goes well, you can click on a character, close everything. And when you've got a channel operators, you've got the value for every single node. So you can see that the node fetch closes blue entity returns 10, 0, 10, write enemy pose attribute returns 10, 0, 10. If you open the channel operator again, and I lost my nodes again. It's a pain. Well, they're here, and they're supposed to also show the value. Sorry, the UI of that editor is quite, it's not that great. We're supposed to fix that, but we haven't had the time yet to do it. Let's see if I can take this, frame it. Well, okay, framing doesn't work neither. Okay, I feel that I'll not be able to. Let's put those nodes maybe elsewhere. Can I move those nodes away? Yes, okay, I can put them here. Yeah, that's going to be more convenient. Okay, great. They were just like stuck in a corner. So I moved them into a different position. So when you click on a character, you can actually see exactly what's computed from that node if you do like a more complicated option. And you can see what's written out into that node. So here it's a simple operation where you just like specify a position, a vector, write that vector into an attribute, and that attribute gets read from the go-to behavior and so on. Does a key works? Let's see. Oh, okay, you just saved my day. Thank you. And probably, oh, I tried F, but I couldn't make that work properly, so I'm not sure if that's supposed. Well, it works as well. Okay, so okay, I was probably unlucky. So yeah, A key, F key to center this for your own use case. So you know, simpler graph ever. Write a value into an attribute and you got it. And you can control bones the same way we've been doing, you know, yesterday with the set bone behavior. Is the same stuff. You can write bone orientation and so on. So what we need to do here, that node is called fetch closest blue entity. So we're not really fetching closest blue entity. So let's see what's available into that input node. So let's go and select the input node. So I've been selecting that guy here. Let's rewind the sim so the sim does not exist. And let's open that list here and see if we got something we can exploit from the attributes. And I think that if I type sensor, nope, sensor doesn't work. Haha. What else do I have? I'm almost sure that there's something related to sensors. So let me figure what's the keyword for that. Cached word, that's PP attributes here. So we don't need those. Bone physics. Bone direction. There's supposed to be something related to. Oh, you can see a closest entity. Oh, sure. But we're now using that sensor we just created. So that works. That totally works. And we may go that way. Closest entity, that's correct. Bone position. I'm like super sure there's something which is related to perception. Bone direction, limb base footprint, blind data, distance to target, bone physics is running object pose. Oh, here we go. So yeah, true. You know what? You can actually use closest entity, and that would probably do something similar to what we've been doing. But I know that I was not using this for my use case because I plan to use half points. So closest entity will not filter if entity have, you know, a half point being superior to 0. So having an attribute being superior to 0. So we'll just return you with the closest entity, and you will not be able to filter exactly what's going on. So what you can do is type in your filter obj for object, and it will return you with some expressions here, some channels that we can exploit. So there's one which is called this dot in bracket behavior name. So probably we need to replace this with a behavior name. Object pose dot in bracket with index. So we're going to bring that guy in, this dot behavior name dot object pose dot indexed. Let's bring that in. And if I was looking at the documentation, so let's bring the documentation for this. So channels, Golem. Let me bring the Firefox here. Channels, Golem. Let's fetch for object pose if we want to have the reference to that guy. And we can see that object pose is a channel which is actually attached to a sensor behavior channel. So an activate sensor behavior or navigation behavior. And it will return the position of each perceived objects. This channel requires an integer component to specify the index of the perceived object. So here we've been like, you know, filtering and keep only the closest one. But if you want to take the second closest, you can remove the max count we put into the filters and say you want to have index at position 1. So 0 will mean the first entity, 1 will be the second, etc., etc., etc. So this is the way we use it. This dot the name of the behavior dot object pose dot the index. So let's replace what can be replaced. So index, pretty easy. What's the value we're going to put here? How do we replace that index? We want to have the closest and the only stuff that was returned. 0, 0, 0. Yeah, good answer. Great. And so this is the first thing we want to replace. And the second thing we want to replace is the name of the behavior. So when you've got, you know, multiple behaviors with multiple sensors, you want to be able to tell which one you want to fetch from. So what I'm going to do is find the name of my behavior. It's called fill distance entities shape. So please take the name of the actual node, but not the name of the transform. Take the node of the actual behavior. So fill distance entities shape. And I'm going to copy this, put this instead of behavior name, and press enter to validate this. So now we're saying we want to take on ourselves a behavior called fill distance entities shape, which is my activate sensor behavior. We want to take the closest, the object position of the first entity we are able to fill. And if everything goes according to the plan, we can rewind the sim, run the sim for a couple of frames, wait for it to update. And now you can see we're getting a position, which probably is different for every single entity. And if we were about to run the simulation, now we should get our characters gathering. And when I select guy, I can see which characters is actually going towards to. And now every single guy has a target and is supposed to reach it. Come on, you guys. Oh, they do not reach it. So there's wait a minute. There's an issue with my setting here. Aha, they're still onto the. So wait a minute. So usually when that happens, open the enemy position. Oh, open the spreadsheet. So the spreadsheet looks good. Yes, okay. I know exactly what's going on here. So that's great. So okay, it looks good, right? So usually when that happens to me, what I'll do is I'll rewind the simulation and I'll do a step-by-step. So I launch the simulation. I can see that I initialize my attribute to 0. Okay, so 0, 0, 0. Then it changes to some positions for my characters. And then it updates. So it means that, wait a minute, my target has been updated, right? So when my target has been updated, it means that probably I need to tell somewhere that some attribute is dynamic, right? Remember this? It's an optimization which we have into our behavior. So what's the behavior which is making path planning? So yeah, that's the go-to behavior. That's correct. So when the target is actually animated, changes, we should probably tell the go-to behavior that it's going to change and you need to reevaluate this at some specific frequency. So we'll need to go into our go-to behavior and that should probably work. And we'll need to tell that expression we've been providing, it's dynamic and we want to evaluate this. Well, every 10 frame will be great. So here, every 10 frame. And well, also what I could have done is probably I would have go into my visual feedback as well, go into my Maya viewport settings, and I could have like asked to show the path to target and the final target, and we can see that the path to target brings the character to 0, 0, 0. So that means my target was not updated, and that probably would have given me like a hint about specifying that my target is dynamic. So I need to check target is dynamic here and run the sim. And now I can see that my characters that are not gathering to that 0 position anymore. They're not converging. We can see they're kind of spreading amongst other characters and they're all reaching different positions. So I just want to check where there's some people who are able to get something similar than me, which means having some attributes being dynamic and having characters gathering to the right place. So there's a yes here. And if it's not the case, please let me know too. Please write no so I can know exactly if I need to, re-explain some of the stuff. So I've got 1 no, 2 no. Yeah, okay. I can see the attribute. Okay, great. So you know what I'll do is I'll kind of review everything I've been doing. And now you can see my characters. Well, they're not doing anything because but they are next to the characters that feel are the closest. So far so good. Probably now is a good time for the people who were able to get this working. Well, then you're good. For the people who haven't this working, let's skip the break. Else, there's a 5-minute break, so you can go away, and I'll kind of re-explain everything here, right? So let's re-explain the whole system. So remember, I think you all have your sensors, right? You're all good regarding if you select a character and the play for more than 6 frames, when you select it and open the visual feedback, you guys all have one character being appearing here, a blue spot being displayed. You guys all good with this? Okay, well, I won't be able to go through this again. But okay, check the stream for more data about this. I got all the characters. Oh, damn. Okay, so, okay, let's go through that sensors again. So if you got everything, it means that you didn't filter the sensors. So by default, so let's go back to what we had by default. Remove. Let's run the sim. So I guess at least you're in that position where you've got all the green guys, all the blue guys. So apparently we're all correct with this. Yes. And yes. Okay, let's move forward with this. So what we want to do is to filter, because here right now we're sensing everybody who's in that cylinder. And we really don't want to have everybody. So we want to add filters. So I'll go through super fast through the filters. Let's make sure that you've got everything blank here. So remove everything you have except that filter line. Remove everything. So you just click on those, remove those, and go back to something which is clean. So the first filter we want to do is we want to filter only the blue guys. So I'm going to go into this, select CRUD entity type. So it allows me to only select the blue guys, press plus. Now I need to configure that filter. So I select it. I can see the list of all the attributes which exist in my scene. Soldier A are my green guys. Soldier B is my blue guys. So I'm going to select Soldier B, press plus. Now we can rewind the sim, run the sim again, run it for at least 6 frames. And if everything goes well, now we should only have blue entities. So far, so good. Let's add another filter which now sort my characters by distance. So let's go back here on my filter main tree branch, and we'll pick another option which is sort by distance, and we're going to press plus. So now we filter the blue guys and sort them by distance. Great. And next time we run the sim, at least 6 frames, we'll still have all the blue guys, but now they return based on their distance. Final stuff we want to do is we just want to keep one. So they're all sorted. So we want to keep the first one. The first one means the closest one. So go back on filters, create a max count filter, press plus. So now you should have CRUD entity type set to Soldier B, sort by distance, no specific option, max count, put a 1. So now it just, if we rewind the sim, play the sim for a couple of frames, at least 6, now we should get only 1 blue spot, which is the closest blue entity for my characters. Great. Next, we create a chop behavior, which is that guy here. So if you hover it, channel operator, the icon represents a T-pose character with somewhere you can type some stuff. So you can create expressions that you can assign to your characters. When you create it, you are gonna need to click on add new output channel to create a new entry. And that new entry, you can expand this to open the chop editor, which is here minimized on my side. So it should look like this without that green node. So it should look like this. Let's rename this right enemy position attribute or whatsoever. And what I'll do is I'm going to tell this node here to write into my Golem attribute on my characters, which is called this dot attribute dot enemy position. So we're saying that we want to write whatever we'll do before, write this into enemy position. A quick way to have it is to use the helper, select enemy position, and use this dot attribute dot. It's the same stuff we've been doing before. And now we're saying what we want to write is within a Golem attribute called this attribute dot enemy position. Great. We want to bring an input node. So that input node, we can create it from the tab. And I can use within the tab the option called crowd chop input. I'm going to connect those two nodes together with either the middle click or left click from one dot to the other. And what I want to write into that node here is what's into my behavior, so the position of my blue entity that I'm filling. So from the helper, once again, I can stop by typing obj and press enter. And what I want to take as an expression is this behavior name object position index. So it means that we can now fetch the position from what we have. So the index of the entity we want to fetch into is 0. So index always starts at 0, which means the first one is always 0, the second one is 1, the third one is 2, etc. So there's a tiny, there's a shift. So we want to take character at index 0. And the name of the behavior we want to read that data from is the name of the activate sensor attribute, so the running guy with the radar next to it. So I'm going to select the name of the behavior and put it here. So I'm going to say I want to read from the sensor an object position at index 0. And if I rewind the sim now and I select a character, well, I made an error. Okay, I need to press entry to activate this or go out the tab. I need to validate the field, else it's not updated by Maya. And the next time I run the sim, now you can see that it updates with some position, and we are writing some position into the spreadsheet. So each entity get assigned with a non-zero position. Finally, what we want to do is to say to the go-to behavior that the target is dynamic, because it takes some time for the target to update, and the go-to kind of remind that you know, just the position of the target was 0, 0, 0. So we want to go into the go-to behavior and just activate the target is dynamic here. So every 10 frames, you would read that attribute again and fetch that position. And hopefully that's now working for you guys. Great. Okay, pasted the bracket. Yeah, it's and I guess you had an error regarding this. If it's not working, you know what? Usually, let's say you put a bracket into your chop attribute. So I guess you had something like this, where you put a fill distance with a bracket around. I'm pretty sure we'll provide you some feedback regarding this. So let's validate this and let's run the sim. And now you can see that you've got something which tells that in node update enemy pose, channel behavior attribute fill distance entity shape is not found. So now it uses a default value. Usually you have to check that you know, you have the correct syntax. You can check documentation for this. Especially the documentation shows you the example, which tells it should be something like this dot sensor dot object pose dot 0. So you can probably figure that the bracket is not required here, and that's providing the wrong syntax. Excellent. So we're kind of running out of time, so I need to maybe move fast with this because so far I've just have my characters which are, you know, finding the right position, but we haven't feed that attack enemy stuff. So I can maybe, well, we can do this quickly. Let's take 15 minutes to like trigger some attack animation. When do we move out that group and go into this? I was about to make it like another sensor so I could show you how you can use another sensor, but probably what you can do, we'll do it differently. We'll do it in a faster way, right? So first thing I'll do is probably I'll create another attribute on my entities, and I'll go on my soldier A, and where we've been creating the enemy position attribute, we'll go back again into this Golaem simulation attribute. We're going to create a new one, and we're going to name this should I attack. Should I attack? It will be like a 1 or 0 state. So what type should it be? Float, integer, vector, int, float, int. Yeah, if it's if it's well, we don't have bool, but integer, it's like a magnified Boolean. So yeah, if you don't have to sample your values with decimals, stick with the int, will be great. So int, and default value for this, should I attack? It's going to be 0, so it means I should not attack right away, else you've got your characters which may attack right away, so that's not exactly what you want. And what we'll do is we're going to say when the distance of my target is less than a specific value, I want to set my should I attack to 1. Okay, let's do this. So I'll go into my channel operator behavior once again, and I'm going to create a new entry, a new output. And this is where we're going to decide how we populate that attribute here. We're going to open the chop operator, and we should have somewhere, let's do A. Okay, A, we should have an output once again. Let's reopen this. Yeah, here it is, but it's not with the rest. So now you should get another output. If you can't find it, you know what, never mind, you can just create it yourself by going into the tab key and create an output node. So you can create as many output node as you want, and I'll show you later how you can attach it to your behavior. So let's, you know what, let's do this way. If you can't really figure where it is, just create an output. So it's going to be red, and we're going to name this right should I attack. Okay, so this is where we're going to write that data here. So we're going to configure that node. So what we're going to write into is a Golaem attribute once again. And we're going to fetch the name of that attribute from the helper. So I'm going to take the should I attack. And once again, we're going to add this dot attribute dot should I attack to tell that I'm going to write it on myself, on my own attribute, which is should I attack, the integer value out of it. And wait a minute. Should I attack? How am I going to do that? Wow, you know what? Okay, let's change our mind slightly. Let's go into, you know what? We'll do a float value instead of a. Yeah, okay. Sorry about that. Let's go back into soldier A. Let's change this. Say it's a float. Wait, because default value will not be good neither. Well, the thing is, I'm puzzled because we can't do inferior into this. So there's some ways to actually, have an integer switching from 0 to 1. And in the next release, we actually have the right operators to do this. So this is why I was kind of doing this way. So I'm not good with that. No, we can't do a comparison with that version. In the next one, we've been adding comparison operators, but we do have like a multiplexer nodes, which are like a heavy way to make comparison, but I don't want to use those nodes. So never mind. I'll do this. We'll do float. We provide an initial value of anything which is non-zero, like 100. And I'm gonna probably rename this entity enemy distance. And we're going to use some triggers later to figure if this is superior or inferior to some value. So, okay, let's change our mind. Let's create an attribute which is called enemy distance, which is a float, which has a default value of 100. And into our output node, the attribute we want to actually feed is enemy distance. So this dot attribute dot enemy distance. It's no big deal if if you're not following that part. You can just well, if you're not doing that part on your side, you can just follow and get the general idea and try it on yourself later. So this node here should not be named right should I attack anymore. It should probably be named right enemy distance. Great. And I want to create another input here, which is going to be called fetch closest enemy distance, that I'm going to connect right into that guy here. So we've got one stuff which provides us a position, target position, and one which will provide us distance. So I'm going to use, once again, we have one of the channel we had which starts with obj, and we've got an object distance here. So I'm going to use that expression. I'm going to paste the same name, so field distant entities shape into behavior name. And rather than returning a position, you will return the distance to that object. So I'm going to say index is 0. My behavior I want to fetch from is field distance entities shape. And now we're writing that distance into this. And if I run this behavior, let me check my attributes. So there's a enemy distance of 100, and oh, it's not updated because right now I haven't plugged it into the channel operator. So remember, I created the output myself. So right now we don't have any output here, so I need to select right enemy distance. So now that graph becomes active for that kind of characters. And let's check here. So now we've got, okay, a distance which is moving down, moving down, moving down, and we never go through 0. It starts at enemy distance -1, okay, and then it goes at 29, okay, and it's going down. Okay, so not so bad. Great. So now what we want to do is stop all that group of behavior as soon as this distance is inferior to some value. So you decide, I don't know, maybe when you're below, I don't know, 1, which means you're 1 unit away from your character, from your enemy, you're going to stop this. So the way you do this is by changing the stopping trigger of one of your behavior. So I can tell maybe, I don't know, the go-to behavior, for example. I can go into the stop trigger. I'm going to open it. And what I want to do is to evaluate if my distance, so my attribute, is below some value. So for that, we're going to use one trigger we've been using in the past, which is the expression trigger. So the driven triggers allows you to fetch a value from Maya. You can connect any attribute from any Maya node. So I don't know, it can be maybe the radius of a sphere, or is an object being visible or not visible. So you can keyframe the visibility of an explosion, for example. And this is when you use the driven. Expression allows you to, fetch an actual expression. So I'm going to put an expression attribute here. I'm going to set it as root as always. And what we'll do is we're going to fetch my enemy distance. Once again, we're going to name it this.attribute.enemy distance. And we want to check if it's below or equal to maybe, let's say, 2. And I kind of fear that probably it will not work, but I have got an idea why it will not work. So let's run the SEM, select an entity, and check the behavior editor, and we can see that that behavior stopped right away. So it's already stopped. So my distance is already less than 2, because for some reason I've got a -1 animate distance here. I'm not really sure where it comes from. Probably it comes from the channel operators. So never mind, no big deal. What we'll just do is but the thing is, that channel, that sensors here, updates itself every 6 frames. So I fear that when we start simulation, it hasn't updated itself. So it's not initialized. Yeah, okay, it's not initialized. So we're not able to fetch the value. And when we don't know what's going on here, we've got a -1 value here. So what we can do is probably just change our trigger slightly. So we're going to say, I want to fetch if enemy distance is inferior to 2, but superior to 0. So I'm going to create another expression here. I'm going to write the same name here in there, and I'm going to do superior or equal to 0. And we're going to combine those two together by saying end. So I want to check that enemy distance is inferior to 2, but superior to 0. And probably that should do the trick. Yeah, that does the trick. So they start. And no big deal if you don't make this through on your side. Once again, you've got the stream if you want to train yourself with this. I just want to run fast so I can show you how you can make archery soldiers. And when my characters get close enough, I expect them to stop. Yeah, okay, that behavior stopped at some point. So great. So now we're good. Characters stop going somewhere. So even if that guy has stopped, we can see that those guys have not stopped here. They're still running. So I can probably like share the trigger amongst every single guy of those, but that's going to take me a while. That's not really an optimal solution. So what you can also say is the parallel node, it has also its own option. So you can ask, what's the situation in which we go out of the parallel and we kick out all the other behaviors? And the default mode to exit the parallel operator is when all the behaviors have ended. So when all the children behaviors are done, I go out and I move into the next step, which is attack enemy. So you can change that option by saying, I want to exit this as soon as one behavior has ended, or as soon as a specific behavior has ended, and you can pick exactly which one you want to monitor. So here I can say either as soon as one behavior has ended or as soon as the go-to has ended. And my final step to make this work would be had a motion behavior here, load it with a battle animation. So fight animation, and we'll have a start of something. And well, in an hour and a half, we can like really make a full battle, Lord of the Rings scene. But that gives you an idea of the full system here. So once again, you'll be able to take the stream and look at this later. And we also need to add, locomotion on our characters, so they're animated while they do the go-to and navigation. That's something we've seen yesterday. And here we go. We've got all the characters start fighting. The other guys are not reacting because we haven't had the time to figure the different behaviors. There are some collisions as well we need to fix with some physics, but you get the idea from what I can get from here. One question is, can't we set an initial value? We actually set one, but the thing is, the channel operator, from the first frame, it overrides that default value. And when we run the first frame, the sensor has not updated itself yet. It updates every 6 frames, so we have to wait a couple of frames for it to update. So you can see here we have to update at least 6 frames to get a position. You can also go into the sensor and say, I want to update every frame, but that's just you're just asking the sensor to compute every time, and it can be really heavy if you got a lot of characters. But yeah, well, you get the idea. At the end, you put 1,000 of those, you replicate the same behavior on the other side, you put some health points to trigger down the characters as soon as they hit 0, and you get a really great scene. We covered this last year when we were doing the live sessions. We've got 3 live of 1 hour, which go through making a charging army with falling characters fighting, syncing the fight sequence with each other, and getting a great fighting sequence scene. Okay, I went like super fast. You can feel that from the chops. We kind of just en français on dirait caresser la surface, mais I'm not sure what's the. We didn't went really deep into that chop stuff. Maybe what I can do is show you a pretty heavy one, like a production one. From the character pack, if you check the scenes, if you go into the scene directory, we've got something called Charging Army, I think. Yeah, Charging Army. And that's a scene from the people at Machiavision. I think it's Golaem. It's Game of Thrones season 7, something like this. And they wanted to be able to drive. Well, we didn't have the right to use the same models than them, so we used that with our own characters and our own motion. So this is why the horse animation is quite poor. There's just one motion in the locomotion, but the steering of the horse, it's driven by some sensors and chops. So you can check the setup here. It's something which is super familiar. It's a locomotion, it's some activate sensor, and some channel operators. So the channel operators are providing a speed and an orientation, and the locomotion is following that rule. Activate sensors triggers 2 different sensors. There's one long range sensor to create that lining emergent behavior, and that close range is to make sure that you don't have any collision. And let's dive into the chops, because this is where most of the magic lies in. Let's close here. So the chops, we've got plenty of sensor input. So sensor input allows you to take your cylinder and filter again within it. So this is what the character sees forward. This is what he sees on his right side. This is what he sees on the left side. That gives you some occupation about where are the other guys. So if someone is too close, if you are too much, if there's too much occupation of that area here, you may want to slightly shift on the right. If there's too much people on the left, you want to slightly shift on the left, etc., etc. So you got long range, far range stuff, and the chop is let's open it. Well, it's not sorted here, especially A. It's pretty heavy. You've got plenty of operators mixed with each other, some mathematical operation. But if you got time, if you got the right mindset, you can create some really heavy stuff. The whole goal of Golaem is to make crowds simple. If you need to do some casual cases, I mean, everything you've seen into the reel, even the most impressive shots, they take advantage of the basic behaviors with some different settings. But if you need to build your own behaviors, like you could have done with Massive, you could do with My Army or with Houdini, that's something you can already also do with us. It's optional, but if you need to, make something more complex, it's available and it's here, and you can do, plenty of different stuff. And we're looking for more feedback. If you're missing some nodes, we'll be happy with this. So you've got a full perception system which can feel the other characters. And you should be able to, get this working properly. So yeah, that was, you can, check that scene. We also have a tutorial on our website which shows you how you can build that scene from scratch and understand every single of those nodes as well. So yeah, I'll let you refer to this so we can move forward and go into another setup here. Okay, I didn't have a break, so let me just stretch myself for a second, crack my bones, drink a bit, and we move forward quickly with our 3 characters. And there's just a question here which tells, I'm building characters where I want a variable to control geometry selection and shader selection. I have 10 face to stick on my guy. Each geo has its own shaders. I've built the shaders with the switch nodes already, but want to drive the selection. I also want to vary skeletal proportions, head size, interocular distance for each face. That's something we couldn't really, we don't have the time to see, but maybe make a support request and we'll redirect you to the right tutorials. We haven't spoke about shading variation at all, which is a shame, but we cover this with tutorials, and you can use the Golaem attributes to drive the shading selection. And skeletal proportion, we haven't had this chance also to speak about this. But we've got a sample scene which is called skeleton overrides, which shows you that from one character here, you can have nonlinear scaling on every bones. So you can use that to, here we just use that to scale up and down the spine, the arms, and the legs, but the body part, the face body part are not influenced by this. So it's called skeleton overrides. That's the keyword you need to search into the documentation. And there's, I think there's a tutorial regarding this, or at least there's a help page which helps you figure how you can make some random variations for bones onto your characters. Shading variation is also covered into full video tutorials or written tutorials. So if you want to have different textures and control this with attributes, that's totally possible as well. Okay, let's dive into, I just want to play with Emmet like super fast. We're gonna create a new type where we're gonna bring, so new scene, bring the soldier fortress because it's the only one who has a bow. Let's bring it. Let's bring the shaders. Soldier fortress AR for Arnold. Great. Into the entity type. So it's my soldier character. Let's go into the rendering attributes, and from the dropdown, let's select arrow attacker to make sure that whenever we're going to populate the scene with those guys, there will have a bow and a quiver. So don't forget to select it in the dropdown, add plus. So now it's assigned to your characters, and put this to 0. So it means that when you're going to make a grid of characters, so let's populate the scene. Change the distance between those guys, noise this slightly. When we're going to create this, all the characters end up with a bow and a quiver and some geometry variation on it. So, okay, so far, so good. All the characters with the bow, and I feel we're going to miss time, so I'm going to speed run this a bit. We're going to assign a motion to those characters. So let's open the behavior editor. And let's assign a motion behavior. Okay, let's double click on that motion behavior. And I think we got at almost the end of the battle directory clip, the battle motions, we've got a soldier shoot arrow golem motion. So it's a motion file, which we have a character which is shooting arrows within it. So let's play the same. So they take something for their quiver and release the string and do this again and again and again. Let's do the usual suspects, variation stuff, change the start frame, change the speed ratio slightly up and down, mirror this. No, do not mirror this because you'll have opposite ends. Right now it's on the bow is only skinned to the left arm. So if you mirror this, you'll have the character handling the right arm with the bow. It's something you could do, but that character is not ready for that. You should have, you know, the bow skin in the two ends, and that's not something which is available on that character here. But let's just change the speed ratio, the start percent, so we already have some diversity there. Great. All good. Let's create maybe another type now, which is going to be my arrow type. So we want to be able to drive the arrows with Golaem and some physics system. So we want to bring another entity type. So let's create another entity type, and let's select my soldier fortress arrow. And we need to have shaders as well. So let's bring the soldier fortress arrow shaders. And maybe I can quickly speak about that character here. So if we look at the middle of the scene, we can see this is my arrow. And I could have maybe done just one bone and skin it to just one bone, and that would have worked. The thing is, I wanted to have, I wanted to define some physics properties on my arrow, because arrows have usually like the head, the tip of it is in iron, so it's weighing more than the rest of it, which is made of wood and some bird feather. So I made two bones, so that allowed me to control my physics properties on it. And I can rename this like arrow character. And just I can show you maybe how does that character looks like in terms of physics. So it has the head tip, which has a mass here, which is bigger than the rest of my body of my character. So this is the wood part, which is like super light, and this is like the iron part, which is super heavy. Well, super heavy, which is heavier. So which means that when we emit those behaviors or those characters, the iron part will always be in front because it has more mass, and it will make a nice arrow stuff. So here, as we drive this with physics, we really want to make sure that the physics properties are set up properly. So let's cancel this. Let's cancel that. And that was just a quick note about that character here. Great. So what we want to do now is to emit some arrow characters from my soldier. Every time my soldiers, they release the string, and oops, let's play this again. Every time they release the string, we want an arrow to be emitted and some physics behaviors to be attached to that. So what I'm gonna bring in here is a new behavior we haven't spoke about yet, which is the emit behavior. It's a standing character which has 3 arrows which are looking towards some particles. So this is the emit behavior, which allows to emit characters or particles. Also, side note, this is what you can use as well to create some drivers in cars. You can emit some passengers with some random probabilities as well. So you can use the random tool as well to say, okay, I want to have always one driver, 50% chance to have a side adult in the front, 25% chance to have someone in the back. So you can use the random operator with the emit to emit characters within cars to populate your cars with actual characters. And I want to put this in parallel of my throwing arrow animation, as always. So let's take a look at what we have in terms of attributes. So the emit behavior tells us how many characters we want to emit. So this is a shared pool size. It's just a way to optimize memory allocation on our side. So how many arrows we're gonna create for the whole duration of that simulation. And here, I guess we've got 60 characters. Most of them will throw up to 10 arrows. So this is the shared number amongst all characters. So let's say here, what we'll do maximum is 600 arrows here. How many entities, well, how many characters will be emitted per entities here? So each character will emit 1 arrow every time that behavior is running. So we're gonna stick with 1. What's the rate per second? So that makes sense. So if we tell it's 10, so what's the frequency at which we emit characters? So here we don't really care about what's the value for this. We can stick it with the default stuff. We need to tell where does that behavior gets emitted from. So here we want to emit this from the weapon. So weapon on the left part. So I'm going to select weapon underscore L. And we can decide what's the radius if you want to avoid, if you want that new character to be avoided in the scene, which is not exactly the situation here. And we can provide some position offset and rotation offset, but let's check maybe how it looks like. And sorry, we need to also figure in which particle system we need to write those arrows. So we can use the same particle system than the characters, or we can create a new one if we want to. And finally, we can decide what we want to emit. So we have the choice to emit either soldiers or arrows. So you can emit soldiers from soldiers, which can emit soldiers from soldiers. So let's say I want to emit soldiers from soldiers. When simulation starts, I've got, that's a weird simulation. I've got a character being emitted from the left weapon. And if I play one more frame, I've got one character being emitted from the left weapon from that guy, and so on and so forth until we reach 600 frames. So that's not exactly what we need to do, right? We want to emit arrows. So yeah, it's an inception of characters here. I knew you'd like that, so I went that way. So let's put back the soldiers to 0% and let's put the arrows to 100%. So now we have at frame 1 arrows being emitted right away. So that's not exactly what we want. We probably want to emit the arrow at a specific timing. We'll figure that later. But also the orientation is not correct. Would like to align this with the actual arm, else the arrow will just go down. So I'll have to find what's the orientation offset here. So what I'll do, I can check on my character what's the orientation, but I'll just do a guess here. I'll try every single orientation, and I'm lucky. Not so bad. Okay, 90 degrees. I was correct. So that's great. So I put just a 90 degrees offset. So it's probably a bit more. It's probably like 95 to get it aligned with the rest. Oops. So yeah, whatever, kind of. Great. So now we've got a arrow which gets emitted almost at frame 1. You need to run a couple of frames, at least 1 frame, to see it moving. And obviously, once it's emitted, it's not constrained anymore to the bone. So when the the animation plays, the arrow just stick to where they are. You can totally like master slave, like attach this to your character so it moves at the same time. But we're going to trick this a different way. So once again, I'm within the emit behavior. I've been putting a 600 pool size here. Only one entity generated. The rate per second I didn't change. I put the bone on which it will be emitted from. It will be weapon underscore L. We want to emit characters from the weapon staff. We want to make sure that we emit particles into particle shape 1, and the type we emit is our character. If you can ignore that error, is not related to Golaem, it's a Maya error. If you don't have your arrow, make sure that you've been running the simulation for at least 2-3 frames. They just take some time to appear. If it's still not working on your side, check the script editor. Let's say you haven't figured the name of the particle system. Probably you get an error which tells you that the particle system is not valid. So provide a right data and make sure that you've got the same stuff here. But well, if it's not working, once again, GCG file is not correct, so it means that the character file has not been installed properly. So means that you need to probably reinstall the character file. Or what you can just do is go into your arrow character and change the display from render previous to physics shape. And you'll see, because here it just means your geometry is not connected properly. So never mind, not big deal. Probably need to reinstall the character maker here. Okay, so what else do we need to do? We need to actually emit that guy only when we release the string. That's the stuff. And also we need that guy to fly over when it's emitted. So let's maybe describe, we'll do this first. We're going to describe some behavior for my arrows. So I'm going to go into my behavior editor. I've got my entity, my soldier behavior graph. Let's create the behavior graph for my arrows. What I want to tell them is right away, when they get started, I want them to turn into physics. So what mode should I use? Dynamic, kinematic, local servo, word servo. What would be appropriate for arrows to be physicalized with? Dynamic, kinematic, dynamic, kinematic, dynamic, kinematic. You make your mind, guys. I've got half. Dynamic, dynamic, kinematic. So remember, we were using kinematic earlier. that when we had some motions and we want the characters to interact with the others which were physicalized. So kinematic means it's fully controlled by animation. And here we will not want to, we don't want to animate those arrows, create a motion clip for those arrows. I want them to be controlled like procedurally with the physics engine. So they're going to be kind of a ragdoll, but as you know, they don't have intelligence and they don't try to catch themselves before hitting the ground. It's a fully physical objects. So we're going to keep them dynamic here. So we're going to turn them into dynamics. And remember, that behavior starts, well, that behavior applies as soon as we stop it. So it's a switcher. It switched the state of the character. So I'll change the stop trigger. I'm going to open it and I'll just select the false default trigger and I set up to true. So when my characters gets emitted, right away, it turns into a dynamic physics object. I can check by running the sim, few frames, and I can see that now the characters, they're falling onto the ground. So they emitted where the arm is, and they just fall into the ground. They don't bounce more because they're made of steel and wood, and I define that properties that way. So they just fall. Next is we want to apply a force because we want to simulate the fact that the string has been applied onto those characters so they fly. So we need to bring another behavior. What kind of behavior we can apply to those characters to make them fly? And we've been using that behavior before. Force. Okay, I'll just get, okay, force impulse. Yeah, correct. That was going to be my next question. You guys are getting tired, not answering me anymore, so that's fine. I'm getting tired too, so no problem. So yeah, you guys, thank you for answering. Force is the right answer. We're going to put that force behavior next. So first we turn our characters into physics, then we apply a force. It will be an impulse. It's not a constant force. It's like the string has been released, we apply a force to the character. So we stick with impulse. We want that impulse to be character relative. So probably on the y-axis, let me like figure this out. So I'm going to put a character relative. So we don't want to be word axis because the character will have different orientation based on what's going to be my arm orientation. So we want it to be relative to the character word orientation. So I figure it's probably on the y-axis because my arrow is pointing towards y. So let me check and let's put the magnitude of, I don't know, 4. I just want to check if they are going into the right direction here. So they're emitted right away and we're going to play a force, but it goes backwards. So it's minus y here, almost there. So okay, they move backwards. So what we want to apply is a -1 axis, and probably because the tip is looking down the ground. -1, magnitude of 4, we probably figured that later. And okay, they flew and they're all gone. So probably 4 is way too much. Let's provide maybe 1.5. Okay, well, it's not big enough, but we'll figure that later. At least it's going the right direction. And final step here is we want to emit those characters only when the characters actually reach a specific frame of the motion. So let's see that guy here. Let's see here, he's playing motion 1 at frame 70 is releasing the string. From 70, 71 is releasing the string. So what I want to do is I want my characters to appear as soon as that motion reach the frame 70. So I'll go back into my soldier character behavior and I'm going to start that emit behavior. So when the characters appear, when the arrows appear, and I'm going to use another expression. So expression is really like the go-to trigger for almost everything, which is like complicated or need to fetch everything from the sim. I'm going to put it as root. And I'm going to check what else I have in terms of attributes. So you can see there are plenty of stuff. So this is why we use that trigger a lot of time, and I can invite you to check the documentation about all the different options. And I think there's one which is called frame. Let me check. Yeah, there's a I just check frame, and we can get a channel which is called this dot behavior name dot motion frame. So sounds about right. I'm going to use that one here, and I need to put the name of the motion. So let's rename this shoot arrow. Okay, that's the name of my behavior. So let's take this, let's put this into my expression. I want that motion frame to be superior or equal to frame 70, and I probably need to make also no, okay, that's good. I think it's good enough. No, okay, it's not good enough. I'm gonna also make another one to say if it's inferior to frame 72, because if the behavior starts directly at frame, I don't know, 110, even if the arm is not in the proper position, you'll have arrows being emitted because it's superior to 70, so that's not good. So I'm gonna just copy paste that expression here, put it there, make it inferior or equal to frame 72. And I'm gonna combine these triggers with the AND operator. So if the frame is between frame 70 and 72, for the arrow. And let's see, up. And we probably need to put some force up here. And you can see that the characters, even if they play the motion multiple times, but the arrow is not emitted multiple times because we need to, loop that behavior again, etc., etc., etc. I'll do like super quickly because we're kind of missing time, but what you can do is put a loop around that emit. You can still like refer to the stream later. Put that emit back into a loop. Ask to end that behavior once it's been played for maybe 2 or 3 frames. So I'm going to change the default stop trigger. So it stops and restarts again. So at frame, after 3 frames. So if I follow one character, for example, let's say that guy here, it starts like it's waiting for the emit to get started. It waits for frame 70 to be reached. So we're almost there. It's going to release it at some point here. Now we're emitting the arrow, and the arrow will fly. So this is the arrow. It's not the right orientation. We can probably fix this. It's ending that behavior after 3 frames and going back, waiting for that motions to be played again. And when we're going to release the string, that behavior will go back green again. Green, emit another arrow. And the orientation is not correct. But now you've got complete emitters of arrows. So yeah, we probably need to change the emit orientation because they're like looking towards. So I probably need to go into here and change my 95 degrees by 85 degrees while you figure this on your side on your way. And probably provide a bigger magnitude. Well, I think, no, that's the opposite, right? 105. It's a trick, but that's the idea. Okay, that kind of ends up, I know it was really, that session today was really heavy because battles are actually really heavy in terms of behaviors. And there were plenty of stuff we wanted to show you today. So I know it's kind of overwhelming. Even for myself, going through this is kind of overwhelming because I don't do this like every day. But that just tells you that if you want, you can do some more complex stuff than just what's available out of the box in some situations. And even with simple graphs, you can start making really complicated stuff by looking for closest entity position that you perceive and so on and so forth. As always, there's as a poll, if you were able to, go through some of the stuff. I do not expect like all of you will be able to go through those, but if you tried it and you couldn't such success in making it, let us know. And we'll know it for the next time. So that kind of ends this year Academy. We probably plan to redo this maybe once a year. What's next for you guys is now, if you want and if you got some time, we provided you with a commercial license. So if you want to make an assignment on your own, be my guest. From the start, I wanted you guys to make a zombie scene, but you know what? Depending on your own favorite stuff, I'll let you decide what you want to do. The condition is it needs to be rendered, it needs to be animated, at least like 5 or 6 seconds will be great. We're gonna make some dedicated videos that we're gonna share with you about how you can convert a Golem character, Mixamo character in some Mixamo motions and create them for Golem. We couldn't really go through those here, but if you want to use some assets which comes from other providers, that'll be great, and I will show you how you can do that. So we're gonna make some dedicated videos for that, and I'd say do whatever you want. You want to make like a stadium and stage this with, nice cameras and nice rendering. You want to make a battle scene. You want to make a city with traffic. You want to make a zombie invasion with a city traffic. Do whatever you want to. As always, as I said, it needs to be rendered. So take the time also to take this into account for the rendering and so forth. And also what we'll do is on May 6th, we'll make a review. So all the works we will have received, we're gonna bring them on, display them, and we're gonna bring some crowd TD, like experienced people, to share their advice, what they would do, how they would do it, and communicate and exchange some advice with you to make the shot better, or congratulate you if the shot is already the best we can do. And we'll run the Discord at the same time, so it will live even outside of the Academy. We're gonna bring, for now it was only dedicated for you for the Academy, but we're gonna invite our customers as well. There's already a couple of our customers, like people we know really well. So we're gonna bring customers into the Discord to also exchange with you and trade. And there are already some people who are like eager to see who wants to be a crowd city and who wants to embrace this as a career, because they're like eagerly looking for people to hire. So if some of you guys liked making crowds, let us know and connect with us on LinkedIn, or connect with the Golem user group on LinkedIn, because we're posting job offers all the time. If you want to make a breakdown, that'll be awesome. If you don't have the time to do it, no problem. If you want to make screenshots of your behavior editor, or just write some text about what you tried, what you didn't try, what you wanted to try, what stuff, sometimes I'm spending days on a feature, on something which you can't really see on the shot at the end of the day, because it's just a tiny detail. So if you do something like this, which you spend a lot of time, which is adding just small stuff, let us know that you spend some time here and there, and we'll be able to share some advice. And once again, for the people who will be sharing their work, we may have some presents to send to your home, so we'll tell you more when it's ready. But just to thank you for following all those sessions, taking the time to make an assignment. We just wanted to thank you. So let me check the polls. So the great thing is most of you guys were able to go through the physics scene, so that's fine. A good bunch of you went through perception, which was really the heavy part. And the archery scene, well, I did not expect you to go through that. I just wanted to show you what's the way of tackling this. But I knew I was going a bit too fast for this. So hope you liked it. Please join on May 6th, even if you do not submit anything, just to see what people have submitted and let this live, a bit more. You've got the licenses, you've got the Discord server. If you need anything, if it's anything more important, like you want to report crash and bugs, and we logged some bugs today and some feature requests. You also have the support. We will redirect you to the support if that's something, a question which is more problematic or something we can't really answer through the Discord. So yeah, the date, it's within the agenda. It's May 6th. It's going to be at the same time than today's session. It's a 4 hour. It's supposed to be a 4 hour time range, but I'm pretty sure we'll not use that 4 hours. We're going to invite some experienced crowd TD, probably the people from Rodeo FX, Method Studios, if they're available and if they can join us. They're already on the Discord, by the way. Those are the guys who are answering you, the crowd department in Rodeo FX, Method Studios, Skyline. So we're pretty heavy studios, and those guys are here. So ask them questions about their experience. And we'll keep also publishing crowd artist stories. You may have noticed this on our website. Every 4 or 5 days, we're publishing a crowd artist story. So people who are just sharing how they went into being a crowd TD. One of the guy, which is now crowd department supervisor at Method Studio, who's working on on the biggest movies and the biggest TV shows coming. He started like you guys. He had a lesson from me in the school for 2 days, so exactly the same content. And he went right away after that, being working as a crowd TD junior for 2 years, then a mid, working on some really heavy show, and he worked on full feature animated. So check his story. His name is William Bobon. He's a crowd department supervisor, and now he's at Meta Studio handling how the crowd department, and he's gonna make heavy stuff. It's not released yet, but it's gonna be heavy. And he started like you guys, taking lessons and being now department supervisor. So that was it for me. Sorry, I kind of went above time. I was super excited about this session. I'm super tired about this session now. But I'm really glad it's done. I'm glad that you guys are still, there's still a lot of you guys being connected. So that's awesome. From that amount, even if only 10 people decide to be a crowd TD, it will be a success for us. So yeah, let us know if you want to embrace that career, and we'll be happy to help you and direct you to the right positions, how to apply, and recommend you. Great. In the meantime, stay safe, connect on the Discord. See you on May 6th, and we'll get in touch with more tutorials to help you with Mixamo conversions if you need. Take care. Hope you enjoy this. Feel free to share your feedback on the Discord if you like that session, if some stuff were too fast, if you wanted to see some specific stuff we didn't cover it, so that'll probably give us inspiration for the next time. Désolé, désolé Tristan. The session will be recorded, so you can attend this later. And also, going through the live sessions we had last year, we made a COVID spread infection simulation that uses the chops really heavily. So you can review the sessions. We got plenty of resources to go back into if you need. Okay, that was it for me. Hope you enjoyed that. Take care. That was great doing this, and we'll see you on May 6th then.